Well, good afternoon, good morning, good evening, wherever you are in the world. Welcome to the Wireless Global Congress, brought to you by the Wireless Broadband Alliance, the WBA. This is the third or fourth session this autumn in the series of webinars being put to you by the WBA. And this is Wi-Fi Connects the World, creating new possibilities in a virtual society. And this is a virtual series of webinars, which so far have been outstandingly successful, both in the summer and here again this autumn. I hope you will really enjoy this afternoon, or today, sorry, probably morning where you are as well. But we have an outstanding set of speakers for you, so I hope you can sit back and enjoy the next period of time. So before I go further, the hashtag on this is Wi-Fi Revolution. So if you are enjoying it or you'd like to comment on it, please reference that, and please tweet and message on LinkedIn as we go on. So first of all, before I introduce the speakers, just a thank you to our sponsors, without whom it might be difficult to put on such an event. So in no particular order, but well, perhaps yes, I should put first the charter members, sponsors, Boingo and Cisco, Intel, my own company, Global Reach, Aptillo, ASIA, Cognitive Systems, Huawei, Juniper, Mist, on single digits, STL 25 and Y Connect. So thank you all to our sponsors for helping us put this on today. So as I mentioned, a really great set of speakers here. We have Carlos Cordiero from Intel, who will be speaking collectively with representatives from Cisco. Dr. Doron Esri from Huawei, CTO of Wi-Fi. Backed by popular demand, Irvin Guy from VP from On Semiconductor. Shantanu Kulkarni, I'm sorry if I've mangled your name, from STL. Vijay Nagarian from Broadcom. Malcolm Smith from Cisco. Tunkai Sil from ASIA. And Chris Begg from Cognitive Systems. So a really great lineup, and I think you'll find this really interesting. This session is really about the future and what Wi-Fi developments in Wi-Fi and what they can bring. And I think it's fair to say within the WBA, our heritage has been around operators and technologies that operators use, but I'm very deliberately focused this session on customers, on both the consumer segment and the enterprise, because ultimately it's about users, customers, and enterprises that offer Wi-Fi for their customers. So if you don't think about those, then we're missing a trick, obviously. So as you can see here, we've got a fair bit to get through, but just as we're just starting to get our head around Wi-Fi 6, guess what? It's Wi-Fi 7, and you'll hear a lot about Wi-Fi 7 through this session, both in the first presentation in particular, from Intel and Cisco, but we'll be looking at Wi-Fi 6 and how to make it smarter with high-powered smart antennae, the whole area of Industry 4.0, the next generation of Wi-Fi, and over the next decade, its application with IoT, how you power the enterprise when working from home in this COVID era, and in particular, the Wi-Fi sensing and what that means for the smart home. So I hope this is going to be enough to really get you engaged. We like to make this interactive. We encourage you to ask us questions, and after each short presentation, I'll be putting questions to the speakers. So please submit those in the chat, and I'll endeavour to put those to the speakers. Just a couple of words for me, really, before we get started. You know, I think we're covering here. You hear about a lot about technology, but ultimately, it's about the user experience for me. A truly seamless, ubiquitous experience and a speed that matches the applications that the user wants to use when they want to use it. And for me, that's what Wi-Fi utopia looks like. Can enterprises and venues identify and engage customers whilst at the same time respecting their privacy? And finally, how do we make this Wi-Fi experience secure, where privacy is respected with a predictable quality of service? And I think all these technologies and the way we work things are going to address one or other of these points, maybe all of them. And I hope I hope you'll find things thought-provoking, and if we're not answering the questions, then please ask them in the question session. So before we start, I'd like to ask you a question, namely, who are you? We're here presenting, but we know you're out there, but we don't know who you are. So we'd like to ask you a question and ask you to describe who you are in your organization. What sort of organization do you represent, and how do you think it would be characterized in these questions here that are being shown on the screen? So simple question: are you a network operator? You're an enterprise yourselves providing Wi-Fi? Are you a hardware or software vendor? A roaming hub or an identity provider? So if you could just click one of those and we'll give you the results of those. It'd be interesting for us all. So with election time happening in the United States, it's all very topical. So let's find out what the audience has said. So exciting, it's coming through. Oh, well, blow me down. 40% network operator, 43% hardware software vendor, 9% enterprise. I'm pleased to see we've got customers represented here. 6% roaming hub and 2% identity provider. So that's great. Okay, let's move on. So I've got only 2 questions. My second question to you is, how can Wi-Fi innovation help? What do you think are the challenges that you're facing? What is it that all this tech you're going to hear about needs to address for us to make the world a better place? So what are the 3 biggest challenges facing operators, whether they're enterprise operators, in a venue, or whether it's a cellular operator or a Wi-Fi operator? Is it data speed? Is it handling concurrent users? Is it the whole area of security, data privacy, and identity management? Is it monetization of and network costs, the commercial side, or is it getting that coverage indoors and maybe outdoors too, but particularly indoors? So if you wouldn't mind just picking 3 of those, and we'll see what the results are. Okay. The people have spoken and the results are in. Wow, that's interesting. That is really interesting. So security, data privacy, and identity management is number 1, joint first with monetization. So the whole commercial aspects of our networks, the whole management of data, security are up there equally at 70%. Then comes handling concurrent number of users and indoor coverage, and then data speeds. Well, that's interesting. We'll wait till we get to the Wi-Fi 7 presentations, because there's going to be plenty of speed. Anyway, we'll see whether we need it. Okay, let's just move on then. Without further ado, we can go to the next. I'd like to introduce our first speaker, which is none other than Carlos Corriolo, CTO of Wireless Communications at Intel. And I'd like to invite him to the stage to present to us on the subject of Wi-Fi 7. What is it and how it will help the industry? Over to you, Carlos. Don't think we can hear you, or at least I can't, Carlos.
I was, of course, on mute. So now I am off mute, and just thanking WBA for the invitation to present here. It's great to be here. So I'll be talking to you about Wi-Fi 7 and what is Wi-Fi 7, what we are up to in the industry. I know that we are right now in the midst of Wi-Fi 6 and 6E, which is really a major evolution to Wi-Fi, and revolution in some aspects. But we don't stand still, and the industry doesn't stand still. There are new demands, new requirements, and I would like to talk to you a little bit about that today. I think we are all very familiar with the current generations of Wi-Fi, all the way from Wi-Fi 4, which was based on 11N, which was definitely a major stepping function of Wi-Fi. And then we moved after 6 years to Wi-Fi 5. And then today, the current generation Wi-Fi 6, introducing major advances to Wi-Fi. It's really picking up. It's a great technology. and it does better in every aspect of the technology, not just speed, but decreasing latency, better security, and better capacity, density, and it's just a great technology. And 6E, which then introduces the 6 gigahertz support for the 6 gigahertz band, and really opens a door for Wi-Fi to become really much better, much more, many more channels, and greater user experience. But the reality is that things are changing around us. New use cases, technologies that are changing around the network are really demanding more. Wi-Fi 6 was definitely, and 6E are definitely a giant leap forward. But what we see happening around us is that the network is changing. Compute is coming closer to the user. We have all these concepts that many of you have heard around network function virtualization, mobile edge compute, which is basically the transformation of the network where the compute now, where in 5-10 years ago, whenever you want to access data in the cloud, you're always having to go to a server that is far away from the user. With the evolution of the network, where data is going to become much closer to the user, compute power is coming close to the user for applications including video analytics, computer vision, robotics. What that's going to lead to is a situation that you see here on this graph on the right-hand side, where as you move data closer to the user from the cloud to the network core to the edge and compute being on-prem, it's going to lead to a demand on the wireless communication that's going to become much higher. The latency here specifically, whereas we had before, and when you go to the cloud, a large portion of the latency will be in the backhaul. Now with compute coming closer to the user, because of the advent of AI and mobile edge compute and all these applications that require very low latency, wireless is going to become a much important component of this overall end-to-end latency. And so we do need, as we look forward beyond Wi-Fi 6 and 6E, to continue improving the experience of Wi-Fi. And that's where Wi-Fi 7 comes. Wi-Fi 7 is definitely going to continue improving on the data throughput, on the capacity. That's something that the Wi-Fi industry knows how to do better than anybody else. But it also has a very unique focus on deterministic low latency. Applications that require a quantifiable upper bound on latency. And Wi-Fi 7, as you can see, is going to be an extension to Wi-Fi 6, an extension to 11AX. It's based on the 11BE project in the IEEE. It's going to support the current Wi-Fi bands. And one of the key requirements of Wi-Fi 7 is to improve the worst case latency and jitter. Today in the project, glad to say that the task group, a number of folks in the industry are working very hard. They have been able to reach a point, my first milestone, which is to have draft 0.1 approved. Some of the key features that are included there is, now that we have 6 gigahertz band, we are doubling the channel size from 160 to 320 megahertz, higher audio modulations in the form of 4K QAM, more spacer streams. But I would also note some really unique features, what we call multi-link operation, for those that come from the cellular background, sometimes also called carrier aggregation, but in a different way. We do that at the MAC level in Wi-Fi 7, and also multi-AP operation, similar in some ways, in some shape or form to COMP from the cellular world. And that, last but not least, deterministic low latency, which really comes to address some of these unique requirements around private wireless networks and industrial enterprises, AR, VR, and many others. Just to give you a flavor for the data rate enhancements of Wi-Fi 7, again, Wi-Fi industry has been really at the forefront when it comes to improving data rate. This table on the left-hand side just shows you the theoretical data rate. From a theoretical data rate, if you just compare Wi-Fi 6 to Wi-Fi 7, we are talking about a data rate increased almost 5 times, where you take the 9.6 gigabits per second that Wi-Fi 6 can provide, you can go up to 46 gigabits per second. If you look at on the client side, what are really practical data rates that you can see on clients, on single devices? The chart on the right-hand side shows you that. It shows you that with the introduction of 320 megahertz channels and 4K QAM, practical data rates in clients, they're going to go from around 2.4 gigabits per second in Wi-Fi 6 to around 5.5 gigabits per second in Wi-Fi 7. And these are just pure PHY data rates. So it's going to be an order of magnitude of at least 2x if you just take a client device. But we don't stop there. As I mentioned, this new feature called multi-link operation, it's really, again, if you're familiar with the carrier aggregation, it's something that you can think along those terms. The idea there now is that Wi-Fi now is supporting multiple bands. It supports 2.4, it supports 5 gigahertz, where in some cases you have the low band and the high band. And of course, now we have the 6 gigahertz now. The idea is, with devices now supporting multiple bands, how can we exploit using these multiple bands in a concurrent or simultaneous fashion? And a device now, a client device, can now be connecting on multiple bands at the same time with the access point. What this gives you is not only an increase in data rate, a potential increase in data rate if you are now using multiple bands simultaneously, but also allows you to use this capability to address different use cases that just don't need capacity. You can use it to, for example, if you need better reliability, you can replicate packets on multiple bands depending on the use case. That's going to also help you to reduce latency. And so multi-link operation is a very important feature of Wi-Fi 7. There's a lot of great work being done there. And if we just look again at the plain data rate, now you can actually add, for example, 320 megahertz channels in 6 gigahertz plus a 160 megahertz channels in 5 gigahertz. That's going to give you an aggregate capacity that can be up to 7.2 times compared to Wi-Fi 6. So it's really a major improvement in data rate. And of course, you can use that also for latency, robustness, and many other applications. So really what we call MLO, which stands for multi-link operation, that's one of the major features and will offer a higher throughput, lower latency that's really needed for many of the applications that we need to address some of the challenges that we talked about in an earlier slide. Multi-AP, that is really the ability to use the multiple access points that you have in a deployment for a given goal, for a given performance goal. Multi-AP is another feature, another topic that under a lot of work in the IEEE as well. There are different flavors, different solutions that are being considered. I'm not going to go into each one of them. I do want to give you a flavor that there are basically two classes of solutions that are being considered in terms of multi-AP. Some that are at the PHY level, that involve topics around coordinated beamforming, being able to basically combine signals from multi-AP, from multiple APs that are nearby a client to increase the SNR at the client, similar to what we also see happening in the cellular world around coordinated multipoint. But also there are some MAC level features of multi-AP. Some of them called the coordinated OFDMA, special reuse, that would basically allow access points to coordinate and share resources in such a way that you can better, provide a better SNR, better capacity, and especially if you consider managed environments, these are really features that can be really be deployed and used, since access points, they belong to the same domain, to the same management entity. And so Wi-Fi 7 really will introduce major new innovations around 320 megahertz channels, wider channels, multi-link operations, and high order modulations, and deterministic low latency. It will build on Wi-Fi 6 and 6E, of course. we will make it even better. Today we have 6E being launched, and with Wi-Fi 7, we're going to make even better use of that spectrum. And overall, by doing that, the goal is that we're going to be able to make Wi-Fi address even more challenging use cases. Continue improving the delivery of use cases around video streaming, video and voice conferencing, gaming, but also improve on delivering to use cases that require deterministic low latency, such as immersive AR and VR. We can also talk about video analytics and many other use cases that are really demanding around industrial, smart manufacturing, and so on. So what I can really summarize to you is that there is a new Wi-Fi being developed right now. There's a lot of new innovation. We are really in the midst of Wi-Fi 6 and 6E. That's the best technology we have available today, but we will make Wi-Fi even better. We really have a bright future. There are great use cases that we'll be able to address in the future and improve on with the emergence of Wi-Fi 7. So thank you very much, and I'll pause here.
Okay, thank you, Carlos. Really fascinating presentation. I have to say, I'm still getting my head around Wi-Fi 6 and the power of that and the benefits of that. What do you I've listened to what you've said, the wider channels, the multi-link operation, the 4K QAM, the multi-AP. What do you think out of those different things is the one? Could you pick one that says, boy, that is the thing that really is going to take it another step further than beyond 6? Because 6 was already a huge step forward on Wi-Fi 5 and its predecessors. So I'm still trying to get my head. What's I can see that it's going to be more efficient and more powerful, but what's the one thing that's really going to differentiate?
Yeah, and I thank you for the question. And I think really the answer to your question really depends on the market segments. I think different market segments will tap on different features to be able to address those use cases. So, for example, if you think of industrial environments, smart manufacturing, the need there is very focused on deterministic behavior. It's not so much on throughput. And so some of the features that are really going to be important for that type of use case will be around QoS, possibly multi-AP to guarantee some deterministic behavior for the network. If you think of other use cases around the home, for example, especially now with number of devices being connected to the home, you're probably going to need a mix. Some use cases are going to require higher data rates, very low latency. If you think people are now doing gaming, teleconferencing, and of course there are going to be use cases that are really going to require a lot of throughput. So if you think of AR, VR, you're probably going to use features around multi-link operation that are going to be able to deliver a higher capacity, but also reduce latency. And so I really believe that when we started looking at Wi-Fi 7, really took a step back, trying to understand the different trends that are emerging, and we really have features in the toolbox that will address different use cases, and which ones are going to stick really will depend on the market segments.
Yeah. Well, I'm hoping we're going to get some questions from the audience. So please, hopefully, Wi-Fi 7 and all its power has stimulated your thoughts and your questions. Are you sure this is not technology looking for a use case? I mean, this just seems so powerful. I'm trying to get my head around how we use it. Is it that we're all going to be stuck at home competing with Zoom calls and my children trying to play games and my wife trying to talk to friends in Australia all at once? Is that what is happening, or
the use of Wi-Fi is exploding? I mean, I don't think I need to tell this audience, especially now with everyone working from home and schools needing access. We all see scenarios where schools, at least in the US, they are taking buses to neighborhoods so that people can use Wi-Fi and stay connected. So the use of Wi-Fi, it's only increasing. And not only just Wi-Fi, but I think what really is important is not just about the Wi-Fi. There are things that are happening around us. the networks are changing. If you see what's happening around the virtualization of networks, and compute now becoming much closer to users, and data will become much closer to users, the use cases that are going to be changing around us, it's going to be dramatic. And as I showed, we really need to keep on improving Wi-Fi, driving lower latencies than we can really achieve today. And I definitely believe, I usually say that it's like disk space, right? The more you have it, the more you're going to use it. And that it's really the situation here with Wi-Fi as well.
All right, I believe you. I believe this is not Intel trying to shift some new tech. I believe you.
No.
Slightly provocative. Okay, look, I hope there's no questions yet from the audience, but I think the next presentation must stimulate you, must challenge you to ask questions. So I'm going to turn now to Dr. Doran Isri from Huawei. He's not dialing in from China, but he is representing Huawei. So over to you, my friend, to tell us about smarter Wi-Fi with your smarter antennas. Over to you.
Thank you, Chris. Can you see my screen?
Yes. Yeah. Well, we can see it with the preview. I think you might want to put it on full show.
Just a minute. How about now? Okay, the most difficult part is just to minimize all these videos, yeah? Okay. I'll try to do it like that. Okay, okay. Great. So can you see my pen?
Yeah, all good.
I cannot, yeah, here it is. Okay, we're all set. So guys, I'm Doran, I'm CTO Wi-Fi of Datacom product line at Huawei. And what I want to discuss with you today is about how we're going to make Wi-Fi 6 much smarter with smart antennas. Yeah, so I'm going to break this presentation essentially into 3 parts. The first part is going to discuss smart antennas. I want to give you like a little bit of briefing about what smart antennas are and why we need them. Then I'm going to discuss about specifically something that I think is very rare, is the interconnection between smart antennas and Wi-Fi 6. And then finally, I'm going to present to you Huawei's amazing design regarding smart antennas. So let's get started. So I'm going to start with like the basic concept. And the basic concept is, I think, very intuitive. I want to compare an access point transmitting with an omni antenna symbolized by this like round pattern communicating with this guy, with this STA. Now let's compare this guy into another AP communicating with a directional antenna with its STA. I think it's natural to understand we're going to get better SNR in the downlink. We're going to get better SNR in the uplink. Not less importantly, we're going to get less interference towards this guy. Yeah, when AP2 is transmitting to STA2, it radiates less energy into the STA1 communicating with AP1. The problem is that these stations in Wi-Fi, they move. So at some other point in time, it would move here and then would move here. So of course, I cannot work with some static or fixed antenna, cannot be fixed. I must work with an adaptive antenna. And adaptive antennas are totally not defined in the Wi-Fi standard. So this is like a totally proprietary solution. So I think it's like natural to understand, to imagine the benefits that you're going to get if you can create directivity towards your station and you can do it adaptively. So let's talk about like the major families that we have in smart antenna. The first one is very simple and very like natural. And this guy says, okay, build a bunch of directional antennas and just switch between them. I think you can imagine that this is like very problematic because if you want to build a lot of antennas, then essentially you're going to have trouble with your form factor. It takes a lot of space. The other family is about phase shifting, and this is what we do in 5G technology. And you know, everybody knows that Huawei is a 5G leader. So just in a glance, and I will have a slide talking about that, let's think about uplink, for example. You're picking up signals from all your RX antennas. you combine them after phase shifting. So each one of these branches, each one can be an omni antenna. Each one of the branches is being shifted by the phase and then combined. I will discuss it. And through this type of shifting and combining, you can create directivity. The most advanced scheme is antenna geometry control, in which I play with the geometry of the antenna according to the pattern that I want to create. And this is what I want to present you in this, to focus on in this presentation. So I think this guy is very simple. I don't need to explain too much. Let's talk a little bit about phase shifting, because it's so important in 5G new radio hybrid beamforming, and then we'll move to antenna geometry control. So talking about phase shifting, and this is like the only equation type of slide in this presentation. Let's think about this guy transmitting and arriving with an array with some direction of arrival. This is like the direction of theta. So if I'm considering what I'm picking up at two different, let's say, omni antennas, one would see a shifted version in the time, like a delayed version with some attenuation. The other one would see something very, very similar. You see, up to this, it's identical to the first antenna, but I also have an additional phase. And this additional phase is due to like the additional distance that this signal is going to propagate. So for example, in our situation, this would be the sine theta. The additional distance depends on the direction of arrival. So I think you can imagine that if I'm changing the phase only of the second branch and I'm combining, if e to the j theta to the j phi here would like totally null out the phase of this guy, then I'm getting a maximal value of 2. And on the other way around, I can turn this guy to be -1, so that the total sum would be totally 0. So I can find a phase that would combine these signals in an appropriate way. I can turn this guy on the head and then say, okay, let's point these guys in specific angles, and then this way I'm going to have an antenna pointing at 0 degrees. Perfect. I'm going to have another one pointing at 30 degrees or -30 degrees. So you can see that, again, if I'm going back here, you can see that playing with the phases and combining can create the directivity of the antenna. This is like heavily done in 5G new radio. Let's talk about the third type. Again, the most advanced. This is antenna geometry control. Let's consider a vertically polarized antenna. I have a monopole. This is like my radiating element. And then I'm surrounding this monopole with passive elements, this guy and this guy and this guy. And these guys can have like two states. On one, they can be floating, like not connected, and they could act like short directors. The second state, they can be grounded, and then they act like long reflectors. This is like a mirror, yeah? They act like a mirror. So you can imagine that if I'm like grounding this guy, I'm going to reflect like a mirror, and then I'm going to create directivity in this direction. Yeah, very advanced. I can control the grounding or floating of these elements. I can create directivity in the direction that I want. Okay, so let's take a look at this guy, for example. I can compare like an omni design, everything is floating, to a directional design. You can see I created directionality in this direction, and I have an additional plus 3 dBi in the direction that I want. Yeah, so playing with the antenna geometry can create directivity. I want to talk to you now that we have like a very basic understanding of this. I want to talk to you about MIMO. And you know, Wi-Fi 6, MIMO plays an amazingly important role. And this is like the second most important slide in my presentation. Yeah, I want to talk about the interaction between smart antennas and MIMO. So you can imagine that if I have like MIMO, I have multiple ports. Each one can be like connected with an array. Each one could be connected with a smart antenna, and I can play with the directions of each one of them. But what would be the right directions for me? So let's imagine a situation where we have an STA arriving at two paths, two directions, one here and one there, and we're thinking about what would be the appropriate beam selection mechanism beam selection mechanism for this situation. So let's play with it a little bit, yeah. So I want to like compare a simple MIMO two antennas of MIMO, omnidirectional with smart antenna of 4 elements. So this would be the performance of the MIMO 2. I have one beam in my setting that comes at one path at 0 dB, another one much weaker comes at -5 dB, and the SNR is 15 dB. So I'm starting with like the trivial solution. I'm considering like MIMO 2, and I see that I started with 15 dB of SNR. I end up with -12.7 dB of EVM, meaning that I lost 2.3 dB due to the, let's say, the geometry of the problem. Let's compare this guy into a smart antenna, and many of our competitors do that. I'm pointing both of my smart antenna devices in the direction of the strong path. Makes a lot of sense. I have energy coming from a specific direction. I want to put my antennas there. Take a look what we're getting. Amazingly bad, yeah. I started with 12.7, I end up with 2, so like I lost 10 dB. I invested in a smart antenna, each one of them 4 elements, but eventually I lost. And why did I lose? Because I didn't consider the MIMO problem properly. Let's take a look at the Huawei way for the same thing. For the same thing, the Huawei would point one of the smart antennas in this direction, but try to gather also the energy from the weaker direction. Again, not natural, yeah, counterintuitive, but take a look at the results. I added 6 dB. I'm 16 dB better than this like bad solution. And the only difference is beam selection. So the message that I want to pass to you is that it's not enough to have a great smart antenna. You need to control it very, very smartly. I think that once we understand that, it's very easy to understand how this guy plays with multi-user MIMO. Of course, that they are very, very good friends, and also with OFDM. So let's move to discuss a little bit about Huawei's smart antenna design. Once we have like a good grasp of the interconnection between smart antennas and MIMO, and we understand that everything needs to be like holistic, then one of the key challenges I think you can imagine when we're talking about Wi-Fi 6, and specifically enterprise-grade Wi-Fi 6, is having a compact design. I want to squeeze into a relatively small form factor, let's say 20 by 20 centimeters. I want to squeeze a lot of elements, and I want to make sure the isolation is great. I want to make sure everything can work both in the 5 gigahertz and in the 2.4 gigahertz, and so on. So the technologies that we are using, and I will try to emphasize it in the next slide, within I think amazing work that our engineers have done, is working with dual polarized arrays. We're working with dual band vertical arrays. We're focusing on the most advanced, yeah, this is the advanced one, antenna geometry control concept, using metamaterials to get better isolation and like to be able to squeeze everything in. We're using the 5G beam training algorithm that we've worked maybe for 100 many years on developing that. And as I mentioned, an holistic solution that integrates both the MIMO detector, the OFDMA, and the multi-user MIMO together with a smart antenna. It's not like an isolated device. Everything has to work together. So let's take a look at this like a beautiful design. So you see, I'll just take a look at the clock. Okay, I have some time. So you see that we have like 4 areas here. This would be A, B. Each one of them is similar, C and D. Each one of them on the top has an horizontal subarray working at 5 gigahertz with 4 reflectors directors. You can see the 4 guys here. On the lower one, it's on the bottom, it's more difficult to see. We have a vertical subarray, and this is like the rocket science that works both in 5 gigahertz and 2.4. This is like a dual band and has 4 reflector director per band, meaning that I can work in one direction for the 5 gigahertz and a totally different direction for the 2.4 gigahertz. Amazing. And for these guys, 1, 2, 3, and 4, we have an additional vertical subarray working at 5 gigahertz that has 4 reflectors director. All these 12 plus 4, 12 in the 5 gigahertz plus 4, squeezed into a 20 by 20. Amazing design, again, that is connected to our algorithm and our scheduling and so on. So to wrap it all up, smart antennas have very deep technological roots like hybrid beamforming in 5G new radio, and the advantages are obvious. We can provide great gains for Wi-Fi 6 APs, and the example I think that I gave you for the single user like speaks 1,000 words. But it's very difficult, yeah? It's very difficult because it has to be tightly coupled and connected with the scheduler, with the multi-user MIMO, with the OFDMA, and so on. So our design is amazingly compact, as the holistic integration, and the performance is amazing. I didn't show due to the lack of time, but you can take a look at this link, up to 30% better than the competition. So thank you very much. And if you have any questions, I will answer with pleasure.
Okay, thank you very much, Doron. Very interesting, and yeah, try to follow all your mathematics there, but very clever. I guess with this technology, much better use of the antennas and the environment. What do you think is the kind of primary use case where you could see this being deployed with maximum benefit?
So I think that, as Carlos said before, Wi-Fi 6, like Wi-Fi 7, and the same is smart antenna, can be applied differently to multiple use cases. So I'm responsible for the enterprise-grade Wi-Fi. So in my imagination, of course, the first use case, first scenario that I'm trying to tackle is the large enterprise. And I think you can imagine that if I can like pinpoint the signal in the right direction, I can minimize the interference to the OBSS. And moreover, if I can pinpoint, and you can think about it, you guys are Wi-Fi experts, if I can pinpoint my signal in a specific direction, then I can like have a spatial reuse on turbo, because I can have one signal in the air and another one picking up at the same time and the same frequency, but I can do it correctly. So what we see at first for enterprises, the impact of smart antenna is truly amazing. For other scenarios like long-range Wi-Fi, where smart antennas play a very important role, we have companies in Israel working specifically on that, and even for the residential Wi-Fi, of course, not a 12+4 element AP. I wouldn't recommend, yeah, buying a 12+4 AP for the residential, yeah. But for example, having a 4-port smart antenna device in your resident would totally change the quality of service that you're getting. So I think the effect that we can have in totally different scenarios is amazing.
Okay, very good. Well, we've had a question from the audience. Maybe it's one for you, Doron. Maybe in fact it's one for our next speaker as well. But the question is, how do you think private LTE will impact the Wi-Fi industry at large?
So I will touch it with a slight revision, and I would say mostly the thing that we're looking at specifically in Huawei, and again, Huawei is a 5G leader, so of course we cannot neglect the 5G front and of course the cellular front. So we're looking at ways where Wi-Fi technology can cooperate in an intelligent manner together, for example, with unlicensed new radio and unlicensed LTE. So specifically in the frequencies where Wi-Fi and 5G and LTE will have to coexist, because these are the same frequencies, then of course we have to, one, make sure that they can work independently in a secure and in a adequate manner. And plus, if we can make sure that happens, then the B would make them cooperate in a good way. And I think, for example, using a cooperation between a 5G or LTE cellular managed network that makes use of Wi-Fi, for example, as an untrusted network, this would be an excellent way forward.
Yeah, okay. Well, the questions are coming in thick and fast, but I'm going to pick one because we're running out of time a little bit. But this says, can this accommodate high density? And I think this is referring to your presentation and the use of the smart antenna. Would you envisage using it in a high density environment, a stadium?
Yes,
or
definitely. The answer is definitely yes. So actually, smart antennas, and again, I come from the enterprise, smart antennas are designed for high density deployments. And in high density deployments, what we care about is creating the directionality of the signals to minimize interference. So we don't care so much about the coverage, because the coverage is not such a big issue in the high density, but minimizing interference is, and the smart antennas, I think, are a killer in minimizing interference. So plays very important role in very high density Wi-Fi networks.
Okay, you heard it here, the killer in density networks. So thank you very much, Dorian. Excellent presentation. Thank you so much.
Thank you, guys. Thank you very much.
Okay, great. Let's come on to our next speaker, Irvin Guy, Vice President of Marketing, Wireless Connectivity and Signal Process in the Signal Process Division from ON Semiconductor. And Irvin's going to talk about enterprise Wi-Fi value add in Industry 4.0, perhaps touching on its conversions with private LTE. We'll see.
Over to you. Thank you, Chris. I'll just go ahead into the slide mode. Okay, you guys can see my screen?
Yeah, it's good.
Okay, great. Thank you. So what I'll talk about is a little bit from what where Doron left off. I mean, and the question, Chris, that you got from the audience in terms of the private networks. I think the technologies are very complementary, kind of what Doron alluded to as well. And they have different price points, they have different benefits, and in many cases, what I'll talk about is how they can coexist to solve issues. And the example that I want to talk about is Industry 4.0. If you just take a look at it from an industrial connectivity standpoint, you know, there's a lot of trends and drivers that are pushing it. There's a lot of you know, media around 5G, but also with 6 GHz spectrum becoming available for Wi-Fi, there's a lot of potential over there. And one of the benefits Wi-Fi, of course, has, like Carlos alluded to earlier, is the strong ecosystem we have in place. So I'll talk a little bit about the 6E value. Obviously, spectrum is one, but there's a lot of feature and benefits. There's additional features that many of the folks are working on at a MAC and a PHY level that further reduce latency, make it more deterministic, which plays very well for Industry 4.0. And what the opportunity is, both from a silicon system software standpoint, that actually brings value to what it's replacing, in many cases wiring. So it's less of a debate between, is it cellular, is it Wi-Fi, and maybe more of a debate between wired versus wireless. And then depending on the different examples that I'll share with you, the different wireless technology might make sense based on the cost structure as well as the latency requirements. And then I think you're going to see this as a theme today. What is the road ahead to Wi-Fi 7? And one of the reasons is many of the folks on the panel today have a silicon background. And when you're in the silicon game, you have to be working on it 18 to 24 months before it starts coming prime time, so that you have solutions when consumers demand it. If you take a look at the trend standpoint, the biggest one, of course, is automation in Industry 4.0. Part of it's safety. If there's heavy equipment, you want to be able to do it with robotics. Some of it's quality. You want to make sure it's repeatability. With a lot of information that we have right now, you can actually use the data to do further cost optimizations. Not all of those are just on the floor. Some of them are data driven. It can be changing consumer patterns, so you don't build too much of it. You have more information and automation to control your inventory, what type of inventory. Connectivity plays a role in all of that. The digitized workflow. One of the things that we have focused on with the pandemic is how many of us are working home and taking care of business from that standpoint. But in some environments like the factory, that's not a solution. You have to be there. But how do you reduce the footprint that you need in the factory? You can digitize the workflow. So I'll give a couple examples of that as well. And then big data and cloud. If we just take a look at what's happening in the retail space, it's getting decimated right now. And the thing that people are turning to is more pointed sales. What is it that consumers want? The lead times to those need to be reduced. And with big data and automated manufacturing, you can make that happen. And that's another reason why connectivity is putting such a big push in the industrial space. And then system integration. It's kind of like what's happening on the network side. We're going from, buying a network, a telecom company buying a network from one vendor and getting the complete solution. And, with 5G, how you're getting a more open rollout, and you're bringing different vendor solutions in. People want to do the same on industrial. They want solutions that work with each other, and wireless-based solutions can make that happen. And then, of course, with the whole wiring from Ethernet going to wireless, you have the benefit that you can do manufacturer retooling. If those manufacturing lines, for example, are hardwired, it takes much longer physically to change them. For example, as a new flagship phone rolls out, how quickly can you adapt? And then shared resources. If you are wired, you're not going to be able to use the same robotic arm, for example, across different product lines. However, if it's mobile and it's wireless, you make that happen. So there's a lot of practical drivers that are pushing this in Industry 4.0. And many of this actually started happening maybe about 36 months ago, as people realized that the wireless technologies will be meeting pace with what the requirements were. Some of the forward thinkers, the large manufacturing companies, were already leaning in this way. And one of the examples, I actually updated this slide over the weekend, was that came out, I think it was Saturday or Sunday, was what Alibaba's doing. Many people think of Pegatron or Foxconn, but very quietly, Alibaba's been actually making a big push in the Chinese market in smart factory. They already had a lot of data on how consumers buy product. They had a lot of data on how people were actually manufacturing and then using their platform and marketplace to sell that product. So what we've been working on is, how do you take all that information and turn it into the back end? How do you make factories smarter? And the big driver for that is really the machine-to-machine growth that you're seeing. The CAGR for that space is 19%. In a few years, I mean, just to give a very simple metric, there will be more machines connected to the web than humans. That it's growing that fast. The overall number of devices to the web might be, or the internet might be connecting 10% CAGR, but the machine-to-machine category is 19. And all this brings opportunity for connectivity. It brings more than silicon opportunity. It brings security, software, for example, headless device onboarding. If you have all those small industrial IoT type devices, how do you board them quickly? How do you do it at a certain portion of your manufacturing line process, so you don't have to do individual SKUs for different vendors, but you can do it at the tail end of the process? All that needs connectivity. AI, big data is a big push. When we talk about that, we all think about the opportunity, for example, on the cloud side. However, there's a lot of additional potential for connectivity in which Wi-Fi can play a role. In the example that I showcased on this slide with Alibaba's Shunxi factory just outside Hangzhou, they actually have connectivity into the sewing machines that they use on the floor. And the reason is very simple. They can change patterns quickly. They are reducing the cycle time on when a designer designs the cloth and when it gets manufactured and available on their digital marketplace, to a couple weeks from 90 days. And the reason they do that is because in a segment, and this is an example, consumer patterns change very quickly. So you have to reduce the cycle time. And the way they're doing it is with connectivity that leverages AI. So instead of using physical dye process to see what the colors are going to be, they're able to use connectivity to bypass some of that process and do digital rendering. All that can be done with Wi-Fi being that connectivity conduit. And then, of course, dollars and cents. I mean, it's a cost and time optimization. AGVs to move material around, they've been around for a while. You can do a multi-vendor floor build, like I indicated in the previous chart, instead of buying just from one vendor. As long as your connectivity solutions interoperate with each other, you can reduce cost. You can buy and build from the best in factory. And then, of course, agile factory. If it's a wireless way on the manufacturing line, you can just simply retool a lot faster. And then, there's always that debate on 5G and 6 gigahertz. And some of it's just, people like competition. But in this case, let's just take a step back. For Industrial 4.0, what is important? I think it's determinism, reliability. You want the latency to be as low as possible. And neither 5G or Wi-Fi will be able to approach that wired latency requirements. So there will always be some applications which fit maybe wired better. But the fact is, a lot majority of them could be done with wireless, and a lot majority of those really depend on what's important. And it comes down to two things: what's the stack and what's the spectrum and their characteristics in it. So for 5G, with the spectrum in licensed, it's very controlled. Yes, you could get lower latency, and yes, you could do private networks. So a operator could monetarily slice different portions of the network for different applications, because you're in a controlled environment. But then if you take a look at it, neither 5G or Wi-Fi have an inherent advantage in this space. The background for 5G or cellular was on the mobile data side, and for Wi-Fi, we have a very strong ecosystem that exists in the enterprise as well as home. And enterprise and industrial have a lot of bleed over. Industrial is not just a robotic arm; it's healthcare, it can be hospitality, and Wi-Fi is already in those spaces. So the advantage Wi-Fi brings to that industrial space is the rich ecosystem. You have so many vendors. You have so many vendors at a silicon level, at a systems level, at an OEM level that provide solutions for that. That competition alone provides, innovative solutions as well as lower cost. So a big chunk of the market for industrial could be served with Wi-Fi. And all that is actually getting more of a push, and we've seen that in a couple of the presentations prior to mine. For example, what Doron indicated from a Huawei standpoint with the smart antenna and how they are able to holistically work with scheduling for both OFDMA and multi-user MIMO. And what Carlos indicated from a Cisco perspective, Wi-Fi 7 brings with multi-link, where you could pair up 2.4 and 5 so that you could replicate packets to improve reliability. All that works towards improving the latency, not just with 6E, like the additional spectrum I'm showing on the chart now, with 1.2 being available in the US market alone, but also the features, Wi-Fi Alliance and WBA, for example, in their trials right now on 6E are confirming the capacity and the speed are going up, and very definitely congestion and latency has been going down. With OFDMA, you get the ability from a stack standpoint to schedule. With uplink OFDMA, this is a big push. If you take a look at the fact that 6 gigahertz will not be supporting legacy client, management clutter has also gone down. And then if you take a look at range and power, with functionality like target wait time, we are addressing that as a Wi-Fi ecosystem, so that helps a lot. And then many of the players in this space are making sure that we support coexistence with features like Zigbee. All that is key. I'll show in a couple examples in the industrial space as well. Now, if we take a look at some of the features, for the sake of time, I'll skip a few because other folks have talked about it. But the big push is the reduced management clutter. For example, if the client is looking at an AP, most of those will have either 2.4 or 5. So they don't need to redo it for 6 gigahertz as they're extracting information. It also, Wi-Fi 6E has rules as how often a client could probe, even in the 6 gigahertz bands. Not all the channels will be scanned. All that reduces clutter. Uplink OFDMA, of course, will help from a scheduling control standpoint, and that's very critical in Industrial 4.0 as scalability becomes key, because many of these applications are going to be in devices that are not in environments that have a lot of interference. And then one of the things that many folks in this space are working on is time-sensitive networking. A lot of work, of course, was done for Ethernet, but how do you apply that across wireless? And that also will improve latency and reliability further as more enhancements are made to Wi-Fi 6E, as well as going forward towards Wi-Fi 7. Very quickly, the Wi-Fi 6E rollout has already started. We're not talking about something that will be happening a few months from now. These solutions are being sampled to customers today. We expect the clients to be there starting Q1, Q2 of next year. And I think some of the presenters down the road are going to be talking about that a little bit later. Many players are involved in that space as well. So, you know, while 5G is starting to roll out, of course, there's some lag across different geographies, but from a Wi-Fi 6, given the fact 6E builds on that rich ecosystem, that's available across multiple geographies today. And then if we take a look at a couple examples, this kind of shows a hybrid industrial network. Like we indicated, it's not just a question of is it Wi-Fi or is it 5G? It's the coexistence across Ethernet, again, which makes Wi-Fi a good solution given their IP background, their ability to coexist. Wi-Fi will take care of a lot of those applications. 5G will be a solution in the WAN area and in many markets where very, very low latency and a controlled environment is available. Examples might actually also include private network. And then in addition to that, Bluetooth sub-gigahertz solutions play a role as well. So if you take a look at examples of solutions, predictive maintenance is one. You can actually take care of that with Zigbee, BLE, Wi-Fi coexisting. It's a very, very cost-optimized solution because those radios have been available for a while. The maintenance is straightforward as well. And all that kind of leads to what type of client devices or what type of solutions will be out there optimized as a technology for Industry 4.0. So even 6E is providing a great baseline. We know how to solve the coexistence issue at a chipset level. So from a system standpoint, customers reduce their time to market. If they reduce their time to market, it's going to bring the cost points for industrial solutions down. We take care of software functionality as onboarding. That just makes it much easier to scale because you can bring multiple devices on board in a factory environment much faster, again, saving money and time. Features like TWT, target wait time, saves you power, which again increases the performance of that solution in that space. Features like BSS color, preamble puncturing are all making sure that if you are in a dense environment, you have a good solution. And then, of course, R2 features like long range location support. I think Chris from Cognitive is going to be talking about some of the work they're doing from a motion CSI perspective. All those applications are value add on Wi-Fi solutions that actually exist today. So there's a lot of applications that can leverage Wi-Fi 6, Wi-Fi 6E, and not even have to wait for Wi-Fi 7 or 5G in the industrial market. And then if we just take a look at what's going to come next, I think as we talked about Wi-Fi 7 earlier, there's a lot on the horizon, and I think Chris, like you did the poll at the start of the presentation, you know, to me actually it's not a surprise that consumers or people in the industry are less focused on the speed. I think if I remember your list, it was really security, for example, as being one, and monetization, both at 70% of what you showed as were the chief care abouts. Not a scientist poll, but definitely not within the margin of error either. If you just take a look at 39% versus 70, and that points to a very hybrid future from a wireless standpoint in this market. 5G adds a lot of value. It'll be around. If nothing else, 5G has had so much marketing dollars behind it that it's really opened up one very simple thing that helps us all, that wireless is a good alternative to being a wired solution in the industrial market. And what we have shown by being able to ship products as an industry is that Wi-Fi 6 is being used today in those applications. The latency requirements are being met. With the work that our companies, that many of us are on this panel, that WBA is doing, we are actually continuing that innovation, time-sensitive networking, Wi-Fi 7 with the multi-link replication, the deterministic enhancements that we see. So the roadmap is very, very rich in a Wi-Fi perspective, not just from a silicon standpoint or a technology standpoint, but the fact that the ecosystem is very rich, and not just in terms of solutions, but also in terms of OEMs that are coming up with solutions that many have not thought of. Chris, I'll give it back to you for questions.
Yep. Okay. Well, we have time for perhaps one question if we've got any coming through. Just a reflection, really, on what you've said. Do you think there's a kind of a ready reckoner you could apply to say, in these kinds of industrial situations, I'd naturally tend to think it would be 5G or private LTE type solution, versus in these applications it's more likely to be a Wi-Fi 6, Wi-Fi 7 solution? Is there a kind of a rule of thumb that we could start to look at, or is it going to be purely, oh, price on application, and we'll see which comes out best?
Yeah, I mean, I think there's some rules, at least with the customer base that I've been talking to. What I have found is that there's definitely networks that are going to be Wi-Fi 6, and many of them are actually ready for Wi-Fi 6E. And then when I talk with the 5G folks, the space I see for 5G is really, like in a telco type controlled network or a private network. But the funny thing is, even when it's a 5G network, Wi-Fi is still there. So either as an offload or as a part of that solution. So while you might have pure Wi-Fi networks that are addressing the cost by, there's even the 5G networks that you will see in the private or in the telco space will have Wi-Fi complementing them. So it's really, from my standpoint, the technologies really are not competing with each other. They're more of a complement to each other, so which is good for all of us.
Okay, playing nicely. It's just the wired guys that have got trouble. Okay. In the interest of keeping us on track, I'm going to leave it there. Thank you very much, Irvin, for your presentation. Comprehensive and fascinating as ever, and some real gems there. I think the whole Alibaba thing with the connecting the back end with what's actually being the users or shoppers are interested in the front end, I think is fascinating. You take a cycle time down from 90 days to 2 weeks. Boy, you can be, if you can be agile with your production to adjust to that, well, you really are making a radical change in fast fashion and fast products and that whole environment. So yes, watch this space. One quick question then, just come in just as I was moving you along. How do you see Wi-Fi 6E coexist with private 5G in Industry 4.0? Do you see the two converge? I think you've kind of hinted that you do, but but I don't want to put words in your mouth. You're on mute, my friend.
I was getting ready for the next speaker. I think yes, I think they complement each other. You will definitely see solutions with offload in the private network as well. So I think yes. So the answer is yes. Now, if there was a nuance to his or her question in private networks in the license space, that would be another version of it, and Wi-Fi 6E could also be a solution in that market. I'm assuming in that, if that was the question, that you could have 5G operating in 6 gigahertz and Wi-Fi as well. You'll just have to make sure from a coexistence standpoint, they work well together. But yes, Wi-Fi 6E will definitely be a complement to 5G solutions in those networks.
Okay, very good. Thank you. Thank you for your presentation and your answer there, Irvin. Let's move on to our next speaker. And I'd like to introduce to you Shantanu Kulkarni. Hope I haven't mangled your name too much, Shantanu. Head of Software Technology at STL. And you're going to talk about the next generation of Wi-Fi.
Hey, hi. Can you see my screen?
Yeah, looking good.
Hey, hi. So it was a wonderful presentations from Carlos, from the full what we heard about the whole Wi-Fi 7. It was great. Then we heard about the whole antenna thing from Doron, and from Irvin about whole industry 4.0. This was a great presentation, and what I see is just taking that ahead. And you know, if Chris, I had a chance to do a poll and I had to see how many of us are connected right now or on Wi-Fi, I can bet that we are around 80 to 85% of the people right now connected are connected on Wi-Fi. I mean, I know these numbers are obvious, but the sheer magnanimity of these numbers, the kind of numbers that they are coming out, are so huge that we cannot, there is nothing other than we can say that we are under this whole blanket of Wi-Fi. There's always some data flying around us. Now, just to understand, we are in this COVID times, to tell you that in India, we are still having in some of the cities some difficult period. Now, we thanked all these doctors, police people, we thank other services, but I suppose that everything to a great extent was possible because of the kind of connectivity that we had. So from my perspective, the people who have given us connectivity in these times are to be thanked equally as any other doctors or police or other services we are thanking. From my perspective, if you look at this, the kind of data that is generated just on Wi-Fi, if you look at it, in a couple of years, we are saying that 51% of the entire IP traffic will be driven only through Wi-Fi. And they are primary because of these four things, because it gives low power consumptions. And we are saying that Wi-Fi is, and we will talk about it, is getting more and more reliable. I suppose that, when we're talking about Industry 4.0, he's talking about really machines working with the reliability of Wi-Fi. We already have a certification of what people are talking about reliability. We can have varied applications, and of course, the most important point about is the using of the unlicensed spectrum. Now, some of the numbers are really staggering. We have on this planet a population of close to something like 7.8 billion people, and we are saying by 2023, 5.7 billion people will be mobile users. Now, just imagine the entire planet. We have all these regions in Africa, we have regions in very, very remote areas. Considering everything, we are saying that 5.7 billion people will be connected by 2023 by mobile. We are talking about 29.3 billion. Again, this was a point made earlier as well, that we will have many more machines connected than humans. So we are talking about 30 billion, close to 30 billion machines connected. In fact, we are starting to call IoT and all these things as a new mobile. The data consumptions we are talking about 44 GB per capita per month. That's the kind of data hungry generation we are. In terms of just machine to machine, the connected cars and all those things we are talking about something like 14.7 billion devices being connected. Now, these are all staggering numbers, and the kind of revenue that they are talking about. We're talking about the economic value. I think, again, we find a lot of details on the WGC site as to how the economy is being generated. Just put in a short, we're talking of $1 trillion economy, more than 3.5 trillion economic value through different enterprises, and everything is generated sheer by Wi-Fi. So the impact on global economy is tremendous, right? And we're talking about currently we have something like 550 something like million hotspots. in about a few years, or I mean in 1 or 2 years, we're talking about 628 million hotspots, which means that especially in the developed worlds or in most of the cities, when you travel from any spot to any spot, you will be always under an umbrella of a hotspot. Like we are talking about, we spoke about this full 5G and Wi-Fi convergence, how they will work. And offload becomes a very, very important aspect. And we are talking about something like $85.6 billion economy that is generated just by offloading. Now, unlicensed spectrum, again, we will speak about it in a moment. The whole pressure on the licensed spectrum can be released only because there is a Wi-Fi sitting somewhere. And we are talking about enterprise getting into this segment, and we are speaking the volume something like $834 billion economy by just 2021. So those are some of the numbers that we are talking about. And the whole evolution that we're talking about, what could be the possible use cases, are, again, there is so much of creativity. Every time you see that there's something new that is coming up in terms of what could be the use cases. But the underlying things that are there to create the use cases are some of the things that, it's a secured access, there is a seamless roaming, there's improved coverage, higher throughput, multi-gig speed, device density. There was a talk about Doran was talking about these antennas. Will those antennas work in a very densely populated areas? So that becomes one of the powerful use cases. We're talking about higher concurrency. We're talking about people going to stadiums where there are many people uploading their videos and accessing Wi-Fi. And will that access be efficient there would become the most important factor. Better channel utilization, roaming standards, quick onboarding, spectral efficiency, and so on and so forth. So there are many things that we are looking as part of entire laying down of Wi-Fi KPIs, you call Wi-Fi requirements, so that all those use cases can be built. To do this, what I'll be talking about is there are a lot of things, but in coming 1 or 2 years, making it very crisp, what are the things that will really determine how people are going to use this entire Wi-Fi thing? Now, we did speak about that people are going to be under this Wi-Fi blanket. There is always a presence of Wi-Fi. We spoke about that there would be offloading from LTE/5G into the Wi-Fi, offloading arena will happen. But to do that, you really need some standard which is of carrier quality. Now, there were presentations made on Wi-Fi 6, of course, on Wi-Fi 7 as well. But definitively in this year, we are talking about a combination of Wi-Fi 6 and 6E, which gives that kind of carrier quality in terms of reduced latency. We're talking about greater reliability. By the way, it's not just about the enhanced capacity or the higher data rate. If you have to really take something which is at a point can be offloaded from 5G, it has to have two very important things in terms of reliability, predictability, in terms of security and other things. So as long as you have these two things, only then you can really make it as a carrier kind of quality. We're talking about one of the biggest thing that will happen is in this IP traffic will be the video traffic. How do you really stream 4K, 8K videos? How do you really give that immersive experience through AR and VR? So there will be a lot of things that are covered under Wi-Fi 6. Now, as I understand that there are many people in this session who are also the software and hardware vendors. So I would really say that, guys, you need to really look at the entire stack when you're talking about the Wi-Fi 6, right from the data plane to the control plane, to ensure that you have software which are cloud enabled for your access point. By just doing changes at one cloud, you can make sure that there are upgrades happening across several access points. You have to ensure that authentication and all these things are already done, which are in line with all the things that you will be doing with 5G. So there's a lot of things that are going to happen from the software perspective also in Wi-Fi 6 to enable that improved experience across the entire Wi-Fi channel. Again, not getting into all these technical details as to OFDM, I think there was already talk about it, that the combination of OFDM and multi-user MIMO gives the ability to have multiple people in parallel to access in a very dense environment The 1024 QAM gives you the ability to pack more data. The TWT allows better battery life by having that sleep time, and BSS coloring for having lesser interference by putting numbers across it. So I believe that investing into Wi-Fi 6 from the software technology, from the hardware perspective, and for the service providers to quickly create a web of Wi-Fi 6 across the cities, especially smart cities if you're building, would be a game changer. The next two things are, like, while Wi-Fi 6 was more on the infrastructure, the next two are more about how do you really monetize it. Now, hotspots, next-gen hotspot also has been talked about for quite some time, but only now do we really see that there is a lot of standardization that could happen. For example, the kind of things that we are speaking in terms of how would you really do a seamless onboarding? How would you do the security mechanism? So we're talking about a very cloud-enabled system where there is a facility to have all those user profiles. So if a user is there at a certain spot for a certain chain of hotels or anything, once he does the user authentication and he travels to any hotspot by that agency, it doesn't matter where it is on the globe, as long as that user is identified, the hotspot can be seamlessly given to this person. I think this is, again, a very big step when we're talking about such high connectivity. Having your entire stack to support next-gen hotspot will be a differentiator. And the third is also an extension in terms of open roaming. As to earlier also, open roaming again is not a new thing, but open roaming earlier used to happen between two partners. So if there is a telco in India and there's a telco in US, they used to come together and do some standards. But now, because of the whole WB intervention coming out with new standards and the way they have put across all these RICs and other things, how two companies can come together and become very soon the partners, because they just have to agree on certain standards. The open roaming can be very, very fast deployed. And this becomes a great user experience, because it's known that when a person goes and he's on the roaming between different cities or different countries globally, he prefers to have Wi-Fi rather than LTE. So these two things become very important from the monetization. There's another thing which is very common as to what kind of analytics can you drive. Now, because there is a lot of user profile which is being stored, there could be, and you know where this user is at a given point of time. So having this proximity marketing, having this reach to that person for that place, and to give him based on that Wi-Fi analytics will be very, very important for one, improved user experience, to provide him a better and a very specific coverage, because you know that what kind of customer he is, but especially to give those kind of advertisements or kind of offers that would be more relevant for that person and that place. So again, repeating, three technologies will make a lot of difference in coming 2 years: Wi-Fi 6, next-gen hotspots, and open roaming before really Wi-Fi 7 comes across the market. 6E we have been already talking about. We believe that there have been already standards now being released. So there are companies who have started making changes according to these standards. Of course, 6E comes with the whole 6 gigahertz, and hence there is much more contiguous spectrum. You can pack much more channels into this thing. It just quadruples everything. There's much more speed, very low latency, and of course, again, coming back to the whole mobile AR, VR, the kind of streaming and all those things, 6E just takes everything much ahead than what was there with Wi-Fi 6, and the cost structure doesn't go so much higher. So considering this, again, 6E will be very soon in the market, and there will be a lot of use cases which will be developed specifically for 6E. Now, what you see on the right are not necessarily related to the Wi-Fi technology. If you look at the whole Project Loon, I'm sure everybody knows about it. We are talking about Starlink, which comes from Tesla Group. We are talking about Facebook connectivity, which is with Terragraph. They are deploying certain instruments across the city in a very dense environment to ensure that there is connectivity. So while on the left we have Wi-Fi, on right it's not Wi-Fi, it's wireless, but they all come together to ensure that there are very advanced use cases, and there is a lot of handover that will happen between these technologies to ensure that there is the whole, we said, as a new mobile in terms of IoT. There should be network slicing to ensure that there is specific services given based on the QAV to enterprise or the users. There's a whole lot of segment being opened up with Wi-Fi sensing, which means it's like a radar. You know, we are talking about smart homes, we are talking about safe homes. So Wi-Fi would be acting as radars, so you know what's moving. How can you do elderly care and health monitoring and so on and so forth. There are a lot of use cases that can be developed from Wi-Fi sensing. There was a talk about this multipath or the bandwidth aggregation we already spoke about, and this is also going to be a game changer when we are talking about how all these LTE and Wi-Fi and other connectivity wireless can be brought together to give a complete experience. So from what we saw is Wi-Fi, open roaming, and new generation hotspot with Wi-Fi 6E. This is going to be really, really something that will change the way people are going to connect. Because for sure, whenever they are indoors, they are going to be under the Wi-Fi coverage. If they are somewhere in the remote area or they are traveling, it could be 5G, and there will be seamless offloading between both the channels. So that's about this thing, and just a kind of a platform stack that STL is working on in terms of the entire stack we spoke about. I'll not read through these, but as I was advising to all the software and hardware vendor that if you want to play, it has to be across the entire stack to ensure that right from the user acquisition to the experience, to the bill payment, to the self-care portal, to the monetization, building in-flight Wi-Fi experience, advertisements, analytics, the whole authentication, it has to be all built in so that a better experience can be given. So Chris, that's more or less from my side. Open to questions.
Great, thank you very much, and I'm going to encourage questions from the floor or from the call. So if you have your questions, please enter them into the chat box there. I was interested in your point, Shantanu. You mentioned about, I think you said, you know, if you have Wi-Fi 6 in different cities that are coming together, can you just expand on what you think that would mean, how that in itself, having that infrastructure in different places would lift things up?
Chris, you were saying what would be I didn't get the full question.
It'd be a game changer. I think I heard you say it'd be a game changer to have Wi-Fi 6 in different cities. And then if you go to the other, can you help us sort of envisage what kind of experience difference that would be for users?
Yes. So look, one of the biggest thing with Wi-Fi is if you go to any malls or any place, there are a lot of Wi-Fi providers. You'll see a list of Wi-Fi providers being there. So for sure, even if you have a very good Wi-Fi capacity, if you're talking about even Wi-Fi 6, there will be a lot of interference. But by introducing this whole 6 gigahertz, you get a lot of space to have a lot of different channels, much more than, let's say, 3 to 4 times more channels than Wi-Fi 6, and that helps multiple users to get connected. And we're talking about very crowded, very dense places in cities where having this Wi-Fi 6E will allow many users to have very low latency, high data consumption. So that's why I say it's a game changer.
Yeah, and I agree with you. The combination of the power of the technology of Wi-Fi 6 and the methods and the approach for open roaming, I think the two together are a very powerful story. One gives you the services, the other gives you the means to onboard the users in a very simple way and scale it. So in the interest of time, I'm going to thank you for your presentation. Very interesting and informative as ever. But I'm now going to move on to our next speaker from Broadcom, Vijay Nagarajan, Vice President, Mobile Connectivity Division. So Vijay, I'm going to hand over to you. Take it from here.
Thank you, Chris. Let me share my presentation. I think I got the wrong slide on there. And
Don't share it.
Present. Okay. I guess the screen is.
Yeah, there you go. Looks good.
Chris, thank you for the introduction. I think it's been a great session so far. I see my friends there among the other panelists as well. So great to hear from all of them. So, I would be remiss if I don't start off with what I was thinking about today as I was walking in. So, I walked into work today. First thing was to actually present this for WBA. And the first thing that struck me really is, hey, if it was an actual, in-person event, then we'd all be there, talking to each other and presenting it live, and it would be a very different experience. But given all the circumstances, given the pandemic, here we are doing an online event, and this is all possible, mostly because of Wi-Fi, right? All of us are on Wi-Fi and doing this webinar on Wi-Fi, right? And much in line with the topic of the day for me, which is the next decade of Wi-Fi. This is what it's going to be. Our next decade of digital experiences are going to be synonymous to the next decade of Wi-Fi. With that, let me go into my presentation. I wanted to split this into three. I wanted to talk about some trendsetters, set the stage, look at what the next frontier for Wi-Fi is, and then also take a quick peek at what our future would look like. I guess which would be more of what we're all doing today. So trendsetters, for us from a Broadcom standpoint, the Wi-Fi 6 revolution started off when we, along with our phone OEMs, launched the world's first Wi-Fi 6 phone back in the spring of 2019. And it kickstarted a whole slew of Wi-Fi 6 devices that came into the market, both on the infrastructure side and on the client side. And I think Wi-Fi 6 as a technology has pretty much been unstoppable. It's been a big trendsetter. If I look at 2019, I would call 2019 as the year of Wi-Fi 6 from our vantage. I think it all started, kudos to the Wi-Fi Alliance and all the companies that are part of it. They came up with the idea of changing the alphanumeric soup that Wi-Fi always had, A, B, G, N, A, C, A, X, to a generational nomenclature. So I think that really elevated Wi-Fi as a brand. It was easy for everyone to recognize what Wi-Fi was all about, and we could instantly see as an industry the tone and tenor of people talking about Wi-Fi, very quickly amplified into a very positive sentiment. Then, for us from Broadcom standpoint, very closely following Wi-Fi 6, the branding, we launched phones with Samsung. The GS10, GN10 were the world's first Wi-Fi 6 phones. And then together with the WBA and a host of partners, we did trial Wi-Fi 6 back in 19. There were a sequence of events that the industry put in place in 19 that really led to the explosion of Wi-Fi 6 devices in the market. By the turn of 2019, there were about 150 million devices in the market with Wi-Fi 6. Come 2020, Broadcom alone, we've shipped about 400 million Wi-Fi 6 devices in the last 2 years, and that's just spectacular. It's just one portion of the market. There are, other chipset vendors that are doing phenomenal numbers as well. So, long story short, the acceleration of Wi-Fi 6 has been tremendous, and it is in part because of the technology benefits that Wi-Fi 6 brings to the table, be it OFDMA or TWT. I think all these features are not just attractive to the home user, not just attractive to the consumer, but also to the enterprise space. And so there was a simultaneous groundswell of support for Wi-Fi 6 as a technology, and that really was a big trendsetter for the industry. And then came this brand new spectrum in 6 gigahertz. In April, FCC took the grand step of opening up 1200 megahertz of spectrum in 6 gigahertz band. And that in just one swoop gave us 3 times more spectrum than what was available till date. Other countries have been following. Ofcoms opened up spectrum as well. Korea more recently opened up 1.2 gigahertz of spectrum as well in the 6 gigahertz band. And what this does is, really open up a slew of opportunities and use cases for Wi-Fi 6 to blossom and for consumers and enterprises to benefit alike. Quick facts about the 6 gigahertz band, and talked to it in the past, but I think it'd be good to look through it again. 1200 megahertz of spectrum. There have been studies that have talked to the amount of value that it brings to the US, more than $150 billion, and then you can sort of extrapolate it to what it means in terms of the value to the entire world. In terms of KPIs, key performance indices, excellent speeds. On a phone today, we can get over 2 gigabits of speed with 6 gigahertz band and latencies of less than a millisecond. And what this means is the gateway for very immersive digital experiences, whether it is telemedicine, whether it's education, all these things that are even more so elevated with the pandemic this year. They'll become more nominal use cases, and then as these use cases become more nominal, you would want more digitally immersive experiences, and that's really where 6 gigahertz comes in. This does support 5G-like performance, which means that a slew of 5G services and use cases could well function in the Wi-Fi, in the 6 gigahertz spectrum with Wi-Fi. And overall, we certainly believe that there's 1.2 gigahertz of spectrum definitely unleashes innovation for the next 25 years and truly maximizes the value that Wi-Fi is going to bring to your life going forward. So that brings me to the next frontier. The next frontier really is Wi-Fi 6E. The slide says introducing Wi-Fi 6E. The speakers ahead of me did talk a lot about Wi-Fi 6E, and people are very familiar with it. But nonetheless, Wi-Fi 6E for us is really Wi-Fi 6 extended into the 6 gigahertz band. When Wi-Fi 6 was launched, when 11AX was launched, this was the 6th generation of Wi-Fi. It had OFDMA and TWT, and on a phone, we could get north of a gigabits per second speed seamlessly. And again, so because of OFDMA and TWT, enterprises loved it because this almost instantly expands capacity for enterprises and consumer use cases alike. With the 6 gigahertz band, 11AX now has the ability to extend itself to a new band and make use of the pristine spectrum that's available. That's where Wi-Fi 6E comes up. Now, where we now have chips that are capable of supporting 160 megahertz of bandwidth and providing north of 2 gigabits per second speed on a phone in your palms. There you go, 2 gigabits plus of speeds in your palms, very immersive Wi-Fi 6E experience, practically the world's fastest, cleanest Wi-Fi, if you may. You're not going to have your lags, you're not going to have your delays. Likewise, extremely good latencies. We've demonstrated time and again that with the 6 gigahertz band, because it's very pristine, because there are no legacy devices in this band, the latencies are in the order of 1-2 milliseconds. Just spectacular. It's going to be super interesting for people that are trying to come up with gaming use cases, as an example. Broadcom, has been in the forefront of Wi-Fi 6, and now with Wi-Fi 6E as well. So back at CES, we launched a slew of access point products that would span, that spans routers, extenders, mesh routers, enterprise access points, carrier gateways. You name it, we have it from a product standpoint, addressing all the segments that are important for the infrastructure market. Likewise, on the flip side, we announced the 4389 around the MWC timeframe for smartphones and AR/VR devices. The 4389 is a high-end chip that supports 2 gigabits per second speed, north of it, extremely low latencies, and has some advanced features that certainly help phone users and AR/VR users. And with that, so we've given you a sense of what the trends were over the last 1-2 years. Just trying to put that into a cogent story here. There were a bunch of trends starting from Wi-Fi 6 and the 6 GHz spectrum and Wi-Fi 6E now. Given that there are a slew of chips that have been announced by Broadcom and others, that really sets the stage to unleash the future for you. As I said, the pandemic has been pretty debilitating for the world, but at the same time, it has taken the world towards a new step, sort of catalyzing digital use cases or digital substitutes for real use cases, if you may, be it working, be it education, be it having a doctor's visit online over phone, or conferences for that matter. So there are a lot of use cases that have been catalyzed towards a transformation into the digital space. So that pretty much unleashes the future for you, right? So truly with Wi-Fi 6E, we now have the ability to make work, school, play, everything from home a much greater success, right? 6E doubles the available spectrum, provides more bandwidth for more devices online. We've seen trials in home where there is an average increase of 50% throughput with Wi-Fi 6E. What this effectively does is, your congestion at home kind of becomes a thing of the past. Your family with a lot of devices makes use of the spectrum more efficiently, is able to pump in more data, support more use cases at the same time from your home. And of course, take your desktop anywhere else, right? So I mean, we are in a world of video calls right now, demands more bandwidth. What that means is, whether you're a remote-ready whether you're a workforce that is, functioning remotely, or as I gave an example, doctors that are, now supporting online calls, video visits. The clean spectrum and 6 GHz definitely gives you the ability to be remote ready and to deliver multiple gigabit speeds. And of course, what would be, I mean, the whole 6E story would be very incomplete if we don't talk about gaming. The fact that you're able to get extremely high speeds and demonstrated low latencies are two key KPIs that would make mobile gaming ever so attractive. Being able to communicate peer-to-peer, being able to communicate from one device to another at these blazing speeds without any lag, clearly means one thing, which is your mobile gaming is now going to the next phase with Wi-Fi 6E. With Wi-Fi 6E, you are going to have literally the best gaming experiences you can, given these two KPIs. Overall, we expect with Wi-Fi 6 and 6E that Wi-Fi will deliver to a host of 5G services. With speeds and latencies, you can see that, whether it is work and play, augmented reality, industrial automation, voice, smart home buildings, and a whole slew of these use cases will absolutely be supported by Wi-Fi, and Wi-Fi would very ably complement 5G in servicing the futuristic use cases. It will also power AR, VR. Think use cases from a compute device to a headset. Think use cases, phone-to-phone use cases, which would now require very high speeds, very low latency. So all these games and AR, VR applications that are coming to the fore now would benefit from, even cleaner spectrum and higher speeds and lower latencies. And if I have to look at all of that in a nutshell, I like to always show this Venn diagram to everybody. Look at Wi-Fi and 5G as being extremely complementary to each other. Wi-Fi 6E and cellular 5G together would amply address 5G services or any of the use cases that are envisioned for 5G. Now, of course, Wi-Fi is so much more than just offering 5G services. And you are going to use Wi-Fi at your homes, irrespective of 5G. Your home networking and networking at office, for example, will all run on Wi-Fi. But on top of it, Wi-Fi does bring value to some of the use cases that are being envisioned for 5G. And as you move forward, the second half of this decade, we expect Wi-Fi 6E would then move to Wi-Fi 7. Now, Carlos talked about Wi-Fi 7 today. I think Wi-Fi 7 is the next frontier and is one that would lead you into not just the second half of this decade, but well after it as well, right? So as a summary, right, and as a snapshot, if you look at what Wi-Fi 7 can do, now we have 160 megahertz capable devices with Wi-Fi 6E. That gets doubled. You have 320 megahertz channels. You have the capability of getting 5 gigabits per second on your phones. It's pretty spectacular. Phones and AR/VR devices capable of doing 5 gigabits per second speed with very low latencies. You can imagine the types of use cases that it can enable. And this is also going to give you better capacity and more robustness for the network. And just a visual snapshot, I didn't put any numbers here, but the fact is, if you compare 80 megahertz, 5 gigahertz solutions that exist with Wi-Fi 6 today and compare that against Wi-Fi 7, literally the throughput and latency benefits would go off the charts. And that's what you're expected, that's what we all expect Wi-Fi 7 to deliver to you in 5-6 years. So as you walk into the next decade, what you're looking at with Wi-Fi 6E and Wi-Fi 7 is that you are entering, as I would like to call it, the Wi-Fi space age. So the next decade is set to be the Wi-Fi space age, and we're all opening up for the next 20 years of Wi-Fi innovation with Wi-Fi 6, 6E, and Wi-Fi 7. With that, I conclude my talk. Thank you, Chris, and thank you, WBA, for giving me the opportunity to present here. Open for questions at this point.
Okay, thank you very much, BJ. And you've probably given us a little trailer to a presentation we got later on about the space age, but I won't do a spoiler just yet. Will I, Chris? Anyway, so I've got a couple of questions for you. 1200 megahertz spectrum is available in the US, but is it available in other countries at present? Are you expecting it to be available in other countries? So I know some of the 6 gigahertz band, and I think top end of 5 is available, becoming available in the UK. And I heard about some other countries. Are you got any insight? Korea, Japan, places like that?
Korea's opened up, right? So Korea's opened up 1.2 gigahertz of spectrum very recently. That's awesome. What Korea's also done is they've opened up a part of that spectrum for what we call very low power devices, meaning it does open up the 6 gigahertz spectrum for us to do device-to-device communication. I think in effect they become the first country to open up 6 gigahertz for device-to-device communication as well, which is pretty spectacular. And I think you would see more countries, quickly following suit. I think the fact that FCC and Ofcom have taken the lead, and another impactful country, South Korea, has also opened up the spectrum. I think I expect these countries and these activities to really be the catalyst for the rest of the world to open up that spectrum.
Okay, another quick question for you, and then we'll move on. When will commercial 6E routers be available?
I think if you were to look at announcements, we've already had a Wi-Fi 6E announcement as of a month and a half ago. ASUS announced the world's first Wi-Fi 6E router, and they're touting that it would be available, I believe, for holidays. I think it's a function of the FCC certifications. Once the devices are able to get certified, I think you would see devices as early as these holidays.
Okay, well, something to do for Black Friday then. Okay. Thanks very much, V-Day. Fascinating, and I find you know, the work that you and Chris have done on leading the way on 6 is just fantastic. So, and 6E, so brilliant. Let's move on now in the interest of time, and I think we've got a double header here, if I'm not mistaken, with Malcolm Smith, Senior Technical Lead Engineer at Cisco, and Carlos Cordero, return of him from Intel. So. Malcolm, are we starting with you? There we go.
Thanks, Chris. And let me just go to presentation mode now, and hopefully we see the presentation. So this presentation is really joint present between Cisco and Intel. And the reasons for that would be pretty clear, I think, as we go through the presentation. But suffice to say that Cisco and Intel have been collaborating in the enterprise space for about 15 years, right? We're talking a lot about how, sort of the enterprise network is, targeted at the IT and the SP customer, and definitely Cisco wants to ensure that that experience is superlative. But the other sort of aspect of the enterprise experience and SP experience really is the user experience, which I think before, if the user experience isn't superlative, isn't better than the previous generation being delivered by IT, there's no benefit to ultimately to the ecosystem. So the goal with the collaboration with Intel is to ensure that the end user experience is the best it can be, building upon the technology blocks we have in Wi-Fi 5 and 6, 6E, and eventually 7. The goal really is to expand upon that sort of basic, fundamental technology platform and make the end user experience the best it can be. That's what the goal we have with all our partnerships. And so far we're focused on the indoor carpeted space, the classic office environment. But now we're moving forward into the IoT space, and in particular the industrial IoT space, which we really talk about a lot during this session today. And so with that, I'll sort of focus on what we see the market developing in that space. It's actually quite interesting because I think a lot of the Wi-Fi market will follow the classic traditional year-over-year growth in the traditional devices that you have on hand today, be it your PCs or smartphones and your laptop, etc. And that will continue to obviously increase in volume as sort of Wi-Fi 6, 6E is roll out the market. But the other interesting thing, more interesting perhaps, that the IoT or machine-to-machine market is actually growing much faster than the traditional, smartphone and sort of device market. And if we think about that for a second, I mean, the classic, smartphone and laptop market is sort of capped by the number of humans on the planet, right? So if you have 7 or 8 billion people on the planet, it sort of caps your market size. But you look at sort of the machine-to-machine or the IoT markets on the right, there's no cap. You can have, each human can have 5 or 10 or 20 or 50 IoT devices, right? And so that market is basically uncapped. As it is shown on the right graph, with a 20% CAGR over 4 or 5 years, we're seeing a doubling or tripling in number of devices. And that can go on forever, right? There's no real limit to the number of devices you can deploy in the IoT space. And especially if you look at the manufacturing space, what we will do in this presentation, it really is quite unbounded. And so that's sort of the key message here is that, from a growth point of view, it could be very lucrative to go after this market. And from a device, endpoint device point of view, sort of uncapped by the population of the planet, which is quite important to realize. And so having said that, then, we look at sort of Wi-Fi. Obviously, we'll be deploying Wi-Fi in the home, as we have today, to provide a excellent user experience for home users, be it they're on their tablets or smartphones or their TVs. And every TV today is Wi-Fi enabled. Appliances, even sort of wearables and fitness trackers are all Wi-Fi devices today. I have one on my wrist. And also AR, VR is emerging for the home market for gaming and educational purposes. The enterprise space follows a similar short trend. We have BYOD about 5 years ago, people brought their devices from home to work with them, and that put a whole new market for smartphones and tablets and laptops that be have dual use. There's also sort of emerging area of IoT enterprise as well, looking at building automation systems and put into the offices, looking at healthcare sector. Every single health, you go to a hospital room today, you will see a bazillion devices in the hospital, right? Go to into a ER room, there's a dozen devices that have to get to the network. It has to connect to the network securely, obviously, effectively, with low power, and very deterministic characteristics around latency and reliability. So there already is a sort of a very strong sort of IoT market in enterprise today around healthcare and retail, hospitality, and so that's very important for Cisco, obviously. But then we look further to the right, then we're seeing that same trend continue into the industrial space. Now, before we say this is a new market, let's recognize that Ethernet's being in the industrial space for about 25 years or more, and Wi-Fi, aka 802.11, was one of the first markets for Wi-Fi back in the 90s. So actually, Wi-Fi has been in industrial markets for decades. Okay, that's one thing to recognize. And so it's not a matter of are we adding Wi-Fi to industrial? The question is, what new markets in industrial can we take on with Wi-Fi 6 and 16? So that's really the question. And so all these verticals in industrial, would be the warehouses, automation, outdoor, oil and gas sector, the power utility sector, the automation, indoor automation, market sector, they're all have Wi-Fi today in some shape or form. They're all used for connectivity for maintenance and operations, used for other purposes. Now, what they're not maybe used for today is the actual connectivity to the actual machine. Let's say the PLC or the logic controller in the factory today. These tend to be wired today. And so the tradition is really between having Ethernet cabling and going to some kind of wireless link. It could be 5G, it could be Wi-Fi, depending on the requirements. Now, if you look at the transition to Wi-Fi, that's somewhat easier because, again, the factory already is Ethernet based. It's based on .11, and Wi-Fi is based on .11, based on Ethernet as well. So this really easy transition between wired Ethernet to Wi-Fi. It's already based on Ethernet technology. It's already based on .11 or already. So that's an easy transition to make. Now, some of the challenges around adopting Wi-Fi in, especially the robotics space, is essentially getting the latency down. I think previously we're not sure how latency with 6E gets sub-millisecond. That's fantastic. But the key way for these applications is, what is the percentile or SLA guarantee I can assure you for that 1 millisecond latency? Is it half the time, 90% of the time, or is it all the time? Obviously, a wired network is all the time. You get that latency all the time. Easy, piece of cake. So the question becomes, can I get that latency 90% of the time, 99% of the time, or let's say 4 or 5 nines, which is very, very high reliability? That's the key problem for Wi-Fi to address. And that's why we're going to talk about that in detail, how we're going to address those, deterministic requirements across the Wi-Fi technology base. The other thing to recognize too, of course, is that this isn't an agile factory. Obviously, agile factory is a big market for industrial IoT, but it's also all the other sectors that cross with the enterprise space, because there is no sort of very clear-cut industrial versus enterprise market. Everything is business critical. So whether it's your heart pump controller in your hospital ER room, or your robot on the factory floor, they both require similar degrees of reliability and heuristic access that make that application viable. Right? And in terms of making it viable, I will pass it on to my colleague and friend Carlos to talk about what technologies are being enabled in the Wi-Fi evolution to address those requirements.
Thank you, Malcolm. Great to be here again, talking to all of you. I appreciate, seeing, not only being able to now be able to see Vijay. Thank you for a presentation, Vijay, but also being able to talk about our collaboration with Cisco, right? And as Malcolm said very well, now this presentation is all about expanding the footprint of Wi-Fi beyond the traditional markets, beyond the enterprise, the home markets, where Wi-Fi is just a table stakes technology, and going to other markets, which we already present. But as Irving said as well when he was talking about Industry 4.0, is the capabilities that Wi-Fi is introducing over generations have really been critical in order to be able to drive towards this vision of determinism, right? One of the things that we often hear from in the market is, well, Wi-Fi is not as reliable as other technologies, and we can always do better. And I think the good news is that with the introduction of Wi-Fi 6, where we started with features like OFDMA and TWT, and then moving on to 6E, which is a major stepping stone in terms of offering more capacity, number of channels, a cleaner spectrum, certainly. And it's going to be really a critical element for industrial deployments for IoT, just because of the much larger amount of spectrum, and better, by the way. I mean, one thing that I think is critical here to note is that there's no legacy devices, right? There's no Wi-Fi 5 or Wi-Fi 4 devices operating in these bands. So that definitely helps significantly in being able to deliver to this vision that we can offer deterministic, low latency with reliability and much greater number of devices connecting to the network. Then we have Wi-Fi 6ER2, which will be introducing additional features, improvements to TWT with uplink multi-user MIMO, of course. That's going to give us better scalability, because now you can have multiple devices transmit at the same time in the uplink. And then that's going to lead to, in years ahead, to Wi-Fi 7, where the industry is already working, as I mentioned in the beginning of the session, on many other features that are going to be able to drive down latency and have better manageability, such as the multi-link operation, the multi-AP coordination, and the better QoS support. So every generation of Wi-Fi has really been improving and driving towards better deterministic behavior with newer features and that can deliver to better reliability and scalability. So we really can today, with Wi-Fi 6 and 6E, drive to this vision that Wi-Fi can have deterministic behavior. And really, to show this, instead of just talking about it, Malcolm, if you can please move to the next slide. One of the things that we did, and we're going to show you now, is together with our colleagues at Cisco, we have really tried to show the beginnings of TSN implementation over Wi-Fi 6. TSN stands for time sensitive networking. I'm sure many of you are familiar with it. There's a lot of talk about TSN today, and we have been working with Cisco on this demo, which we're going to be showing to you, and I'm going to describe that so that you understand what you're going to be seeing in just a minute. It's on the right hand side. So what you'll see here is a demo using a robot. That robot is going to be controlled by humans, and that human is wearing a glove, and they're going to have cameras that are deployed around the user that is wearing the glove. And as the user moves the hands and moves around the robot, right, is going to be replicating those same movements. So the robot is going to have, it has to be very low latency. We are talking about low single-digit latencies here. The cameras capture the data. They send that to an access point. We have an application server that runs at the back end of the access point that is basically capturing the movements of the hand and translating that real time and sending that back to the robot. That is essentially sending back the comments to the robot, and that the robot is going to be replicating what the user, what the human is doing as you move. So there is elements here, for this type of thing. By the way, this has to be done even when you have in the presence of background traffic. And so what you'll see here is the first demo that we've done, and we continue working with Cisco in furthering these concepts of TSN low latency implementation through the implementation of features that we talked about before, .11, .1 QBV and QBU and so on. So Malcolm, if you can click the link, hopefully you have the video ready there. Hopefully the audio is going to work. We'll see. There you go. So hopefully you can see. Let's see if you play here.
Gonzalez from Intel Labs. In this live demonstration, we will see a system that enables human-robot imitation in a high-performance, low-latency process. What we see is a series of elements that enable us to connect the physical real world with the cyber-physical world of the robot. This process is enabled through a series of technologies. First, we have to capture the physical world, which implies my hand within this working space at a velocity and a reliability that is fast enough and reliable enough that there is no lag and there is a fluid transformation of positions of the robot so that turns into a trajectory which couples my physical actions with the robot. In the first step, we will capture my hand through the means of these markers and a network of cameras that enable to establish the position and orientation of my hand by basically capturing each of these markers at 240 frames per second with a 1 millimeter precision. With this information, we create a kinematic frame that enables us basically to transfer my position as a 6-dimensional vector to the robot. On the other hand, the robot will take this information to execute its following the theory in a way that it would be basically smooth. The next step is once we capture this information, it is computed at the edge and is transmitted to a wireless network. This is a Wi-Fi 6, and then it goes into this high-performance Xeon server where most of the computations take place. The process in the server is basically concerned into taking the position and orientation of the human hand and compute the inverse kinematics so that the robot can transform that position into joint angles and therefore into a smooth trajectory. Let us run it. As you see, at the moment we start the application, the engaging of the robot with the human follows a policy of a smooth trajectory so that there is not an abrupt control. Once we have this engaged position, the next policy enables us to have a very compelling, continuous application of all the elements from the perception, the edge computation, the Wi-Fi transmission of the perception, and the commands of the joint control for the robot. Now, in order to achieve this low latency, there is a need to have a computation with multiple cores in such a way that each of the elements of this pipeline are capable to be executed with a thread affinity associated to a single physical core. That ensures that we minimize the latency in computation, but also we minimize the process overall. As you can see, we can execute smooth trajectories, pursuing motion that will be very suitable for fine manipulation, or even in situations where you will have to have a fast response. This will enable applications in terms of remote control of robots and other servo-actuated mechanisms that will ensure maximum application of Wi-Fi 6 and Xeon processors in large-scale applications for robotics in multiple domains. Thank you.
All right, thank you very much. So we just wanted to give you a glimpse of what can be enabled with Wi-Fi 6, 6E, and TSN, enable really very low single digits latency applications. So with that, I'll stop here and see if there are any questions. So Malcolm, I hope you're still around with us. I cannot hear Chris. I don't know if it's just me.
No, you can't hear me because I'm on mute. Thank you, everyone. And thank you guys for your presentation, both of you. Great video, bringing it to life there. Are there any questions coming through from the floor? I'd love to hear them. I have a question actually about Wi-Fi 6, which, a number of you could probably answer, but the question was, what happens when most APs have been upgraded to Wi-Fi 6E? And when do you see this happening? And in particular, would there be congestion issues in such deployments? Do these things kind of trip over each other?
Yeah, I'll let Malcolm address that. Malcolm, are you around?
Yeah, thanks. Still here. Let me share my So Wi-Fi 6E we're expecting to be deployed sometime around the second or third quarter next year. As far as like enterprise rollout, because obviously customers that want to adopt new technology have to go through a validation and any sort of trial phase before deploying. But sometime next year we expect 6E to be deployed, and because of the spectrum availability that will be discussed, having up to 1.6 megahertz channels, that brings you the massive amounts of bandwidth to spread the device. But enterprise, typically you wouldn't deploy channels that densely or that wide typically, so you wouldn't really expect to have a much congestion. In fact, having the wider channels and having the 1.2 gigs of spectrum available to us, as we have with 6E in the US at least for now, gives us the ability to deploy those wide channels in an appropriate reuse factor, which typically is 4 to 5. So to ensure there's no, let's say, co-channel interference, typically you deploy at that sort of ratio, and that ensures that the neighboring APs on the same channel don't really cause interference at all with your network. And so we do expect with 6E to have very, very, very low interference between the neighboring cells. That's very, very good for Wi-Fi 6E because it means that there's no essentially collisions between various cells. Because again, with Wi-Fi 6, we have this uplink scheduling function, which ensures that none of the stations contend in a single cell. But now with 6E having the much more spectrum available to us, we can deploy much wider channels with no interference between the cells. That gives you a very, very high SLA and a very good experience for both the ITSP and also the end user.
Okay, pretty comprehensive answer. Thank you very much, Malcolm. Okay, I think in the interest of time, we're gonna move on to the next speaker, and I'd like to introduce Tunchai Sil. I hope I've pronounced that correctly. Chief Strategy Officer at ASEA, and who's going to talk about empowering the enterprise in the work from home era. We're all living that dream, if that is a dream. We're living it. So I'm going to hand over to you.
To work from home as a productive team without connectivity issues, with peace of mind. Introducing Kpis. Higher worker productivity, better connected remote teams. Because one bad connection means a decrease in productivity for the entire organization. Kpis brings visibility and reliability to essential collaborative business applications. The industry's first enterprise and SMB IT tool for managing residential connections. The platform seamlessly pre-integrates with an ecosystem of ISPs, enterprise tools, and applications. The new normal starts with a strong connection. Learn how you can be a part of the Kpis ecosystem.
Okay, thank you. So Kpis is our new platform. Kpis is our new platform to handle the needs of the home teleworkers. So you just watched a video essentially and talking about very high level the types of components we have in this solution. So today I'd like to talk briefly about what this problem and solution set is. But before I do that, I'd like to thank all the speakers. I've been in the Wi-Fi industry for quite a while, and last couple of years actually is finally the start of the most exciting times for Wi-Fi. Both Wi-Fi 6, 6E, and hopefully 7 is actually getting Wi-Fi to an entirely different application domain. And a lot of speakers went through the industrial and some business applications. But this particularly why I'm excited about this is there are so many different residential and residential-like use cases that are also diverging from their past, and they look a lot more like the traditional business cases, or what Intel and Cisco have been talking about, the deterministic applications. So I would like to take that idea a step further and talk about democratization of basically having better internet connection for all the workers, right? So that's actually the vision of this product line. And I'd like to tie that to a couple of recent news. As you very well know, over the last couple of months, the temporary work from home policies start changing towards a more permanent work from home policy trend across big and small companies. So this means this trend is here to stay. So we're now entering into a new way of working. So we talked about problems of monetization in these new technologies, about Wi-Fi, 5G combination, etc. But apparently, this new trend that we're talking about immediately has a very robust total available market. Let's say if you carve out as a first step, if monetization is concerned, the first billion people in the world, as you select the geographies where the willingness to pay is high and income levels are high, of that billion, about 150, 160 million people are pretty much in this bucket of available end users or paid nodes. So that's quite a bit, and I think this is going to be a big driver of all these new technologies to get to market, not just in pockets, but also ingrained in day-to-day applications and work. So I think this trend, not just the COVID, but working from home, is offering a different way of monetizing all these new technologies. So I'm pretty excited about that. I'm going to keep giving summaries of these topics, but I would very much encourage everybody to go to our new website, keep.ai. We have a lot of research documents, videos, blogs. These are not necessarily trying to push our products. We are trying to help the entire industry have this perspective. So please use it, copy it, and you can have much detailed explanation of these concepts, numbers, not just from us, but also the heavy hitters in the industry. The second topic here is on the business side, enterprise side. This work from home is bringing next level of productivity gains, and this was basically observed before the pandemic as well. There were many academic studies, but after the pandemic, of course, this became even more clear at the larger scale. So what we're looking at here is, in the lower end, you're looking at about $10,000 to $12,000 per employee in savings or productivity gains, and there are a couple of drivers for that. On the easier end, less cost for office space and office-related items, etc. but also there's certain productivity gains related to the flow of work, better utilization hours available, etc. On the higher end, so these are the companies that generate much higher revenue per head. So these gains actually are in excess of $25,000, $30,000 a year. So these numbers are quite big. So that's another supporting point for bringing these really amazing technologies that we covered today to market. I believe because of these inherent savings during this through this trend, the monetization problem for these new technologies are going to be much easier this time. So I'm quite optimistic. So in terms of the problem set, I am, because of the nature of the products that we've been dealing with and customers we work with, which are tier 1 large service providers, I'm a little more in the domain of dealing with ugly problems, right? I'm not in the domain of dealing with sexy problems, if you like. So, and some of these ugly problems show their ugly head in the first days of COVID, and they still go on. One example is we're serving about 35 million homes just with the Wi-Fi products we have today, and about 120 million homes with some other fixed line products. So we have some data across 4 continents, 5 continents. And a summary of that data, as you can see in this chart, is about half, a little more than half of the people working from home actually experience some kind of severe connectivity problem at least once a month. And what's more interesting is about 15% is experiencing these connectivity problems daily. And about 8% is experiencing these problems in a way that it's disrupting their work. So these numbers, as you can appreciate, are huge. So whether we introduce Wi-Fi 6, 6E, Wi-Fi 7, so we have to make these technologies address these problems, right? And this is more about the application, more than the technology. It's how we apply these technologies, how we make sure that these different bits and pieces of technology deliver benefits, right? How we stitch them together, how do we bring interoperability, how do we open this up? So that, all of that discussion corresponds to significant operational expense on service providers and significant productivity loss on the enterprise end. So this is apparently a huge issue. So to address these issues, we have introduced this new platform called Equip. The idea here is to first predict what can go wrong given the footprints of the problems we see. What can go wrong in the work environment at home? So how is this work environment different? What are the application specific needs, etc. So to do that, we had to develop from ground up a different kind of QA prediction system, because this doesn't necessarily look the same as in the residential QoE monitoring systems. So based on that prediction platform, we also built an automated solution delivery service. So in order to do that, of course, we had to build essentially a platform that integrates with the service providers' backends and operational systems. So this system cannot reside on its own and just work magically without the need for any kind of cooperation if we want to automate the solutions to the problem. So these kind of solutions we're talking about is bringing a redundant connection, not on the wireless end, but also on the wired end. Also go towards a more stable Wi-Fi connectivity in the home using many different hooks available in even the existing technologies. We work with a lot of different chipset vendors. Since ON and Broadcom are present here, I'm going to mention their names. We work with their chipsets, and there are a lot of different capabilities already exposed in these chipsets that are not necessarily yet used to address these problems properly. And we put some effort into these, and we just find out that there's a lot of room for improvement. And with the actually it's the Wi-Fi 6, Wi-Fi 6E discussion even brings more capabilities, but we need to take these and apply to the needs of the Wi-Fi connectivity for the purpose of work from home, because the optimization schemes are quite different. So, for example, the enterprise Wi-Fi applications in an office, the use cases are quite different than, or the needs are quite different than the work from home needs, right? So the typical attitude is, okay, well, if I'm working from home, yeah, I have my residential use cases, I have my work use cases. So somehow, you know, they should all be managed together in one seamless way, etc. Well, it depends. There are many different kinds of work, many different levels of sensitivity to security or application performance, etc. So it's not that simple. So we are essentially bringing what's available in terms of technology domain to address these applications. So both on the WAN side, Wi-Fi side, but also we're overlaying the security management and live support, and all with incorporation with the service provider. But our focus is to pull the enterprise customers into this platform and marry the solutions from the ISPs to really solve the specific needs of people who work from home on many different use cases. So this, in a nutshell, is what the Kpis platform does. And as I mentioned, the main benefit here for the employer is to enjoy the productivity gains. As I mentioned, these numbers change from depending on the type of the business customer, and they are in the anywhere from $10,000 to $35,000, $40,000 per employee range, depending on the function. And for the employee, this really is about high productivity and just being able to focus on work, so that you don't have to call AT&T on Comcast and just hear, due to COVID, the wait times are much longer. You're going to be waiting on this line for an hour, or somebody will call you whenever they can. So this needs to go away. Employees needs to just do work and not worry about connectivity. So this is the main benefit to them. And the ecosystem, and in this case, it really, the main participant of the ecosystem has to be the ISP, because wired or wireless, in-home or last mile, all of these technologies need to be integrated for specific solutions to the use cases related to the teleworker. And for that, of course, this is rewarded by very lucrative ARPUs, increase in ARPUs or new ARPUs. And I believe this is going to be a catalyst or a driver for adoption of all these beautiful new technologies that we discussed today. So essentially, if we were to sum up all these discussions and the components I just mentioned, we're looking at, on the device side, a different kind of interaction with the work use cases. And we believe that the telework devices, or designation of some devices as telework devices, or putting profiles on them or treating them differently, especially for security purposes, is essentially the very first step to understanding what needs to get optimized, what needs to get monitored, how the technologies are going to be integrated with each other. So this is the starting point. Then, of course, there's the home networking hardware, and to a degree, the demarcation between the last mile and the home environment, all the equipment that provide that. There is tremendous amount of technology upgrade there. We would love to facilitate that. It's very exciting times. And we believe that the most important thing that needs to be done, both on wireless, Wi-Fi, and the wireline side, is, no matter what the technology is, to bring redundancy, to bring some alternative means of accessing internet. Now, offering deterministic type of connections is actually a very, very good step. But no matter what, there has to be some alternative line. So all of that we try to manage remotely, and all of that we try to we try to predict what's going to happen, who needs what service, what kind of optimization, and how do we deliver the solution in an automated fashion so that people don't need to call somebody, ask for help, troubleshoot, and somebody basically has to get in the house after a call, etc. We'd like to automate all that. So there's a huge integration effort that we put into this platform. And as I mentioned, I just wanted to give everybody a teaser on this platform, as opposed to make a case for every single benefit or the functions. We have many different videos and resources available, and we would also love to hear from everybody. So I will be available for any questions. So Chris, thank you very much again for having me. So I'm more than happy to answer any questions.
Okay, thank you very much, Tanguy. Questions from the floor? I mean, if this is not something that touches all of us, I don't know what is. We're all living through this change of working experience, and as you rightly say, some people have got better connectivity at home than others. I was sort of crossing my fingers when we played the video from home previously, but we got away with it from Intel. But I guess you guys at Intel and Cisco have got great connectivity at home anyway. But I can see the challenge there, and some pretty interesting numbers there to use as the resource. I for one are going to have a look in your website. I'm just seeing if you've got any questions from the floor, but clearly, you know, maybe this is going to get rid of the confusion around settings and all the rest of it. I don't know, from different platforms, if you integrate them all. That's certainly the problem I seem to have. Given the interest, oh, yeah, no questions now, but given our time, I'm going to move on if you don't mind, but thank you very much for your presentation, really thought-provoking.
Thank you.
So Chris, you've been waiting patiently with that super colorful picture behind you, which I keep looking at. Can you take us home with the standardization of Wi-Fi sensing, delivering the next generation smart home? Chris Begg,
all right, I would be happy to do so.
Architect of Cognitive Systems, over to you.
All right, can you guys see my screen okay?
Yeah.
All right. Well, first of all, to start, thanks everybody for joining my talk today. Also, a big thanks to the WBA for organizing this session and putting together such a great panel of speakers. For my presentation today, I've got something a little bit different from what I've shown in the past. I hope what I present is fun and helps stimulate everybody's imagination. So to start, just a quick introduction. For those of you who haven't seen any cognitive presentations before, what is Wi-Fi motion and how does it work? Well, Wi-Fi motion is the technology created by Cognitive Systems, which consists of software that can be added to many existing routers, access points, or gateways, and it can be delivered typically in the form of an over-the-air firmware upgrade. What this technology does is, by analyzing signals transmitted from other devices in your network, it allows you to detect motion within your home, much as a radar system would. Currently, we have 3 products, which have either been launched or will be launching soon. Our first product, we call it Home Aware. This was made available beginning of this year, either as a direct-to-consumer product through our partnership with Plume, or as a business-to-business product offering. Home Aware provides all of the most basic motion sensing capabilities and APIs, essentially allowing for a do-it-yourself home network monitoring solution. Our next product, we call it Family Aware. This is expected to launch sometime Q1 of next year. And what Family Aware does is it provides additional level of insight into the home, such as time the house wakes up, time the house goes to sleep, and activity patterns of the family. Finally, we have Caregiver Aware. And actually, I think this is going to be our most exciting and impactful product yet. What Caregiver Aware does is it provides our aging in place insights, preventative health, and it provides alert to caregivers and any other. Oops, my apologies. Getting that call here. Oops, sorry about that, everybody. Yeah, so sorry. Yeah, it gives us insight to alert caregivers of any unusual patterns that happen in the home. Now I want to take a little bit of a shift. I want to highlight some of the challenges that are involved with sensing, and to help us visualize, I want to make a comparison with astronomy. Astronomy is the study of everything in the universe, and even though we're dealing with different magnitudes, in many ways, sensing objects in a home environment requires some of the same concepts as mapping our solar system, galaxy, or even the universe. At the fundamental core of both astronomy and sensing is a model. The model is used to perform predictions based on observations and transform measurements into physical quantities. With astronomy, we use physics and mathematics, which consists of many branches, including relativity, electromagnetics, thermodynamics, and many more. Mapping and understanding our universe requires combining everything together into a model such that we can use it to piece together the clues that we get by performing different measurements and experiments. With sensing, we also make use of physics and mathematics, but our models are more specialized and tuned to specifically for the application, whether that's motion detection, breathing detection, or any other use case that we've implemented. Our motion software that gets added to the access point consists of an algorithm which uses our model and measured observations from the radio that we use to make predictions when motions happened in the house. With astronomy, we rely on measuring electromagnetic waves, and we try to utilize the full spectrum of visible and non-visible energy to build our understanding. These waves originate typically from faraway stars or galaxies, and they propagate through space towards Earth, interacting with other objects in space along the way. Different wavelengths have different properties. Some pass through objects easily, whereas others get reflected or even attenuated. But the key is, without these distant sources emitting energy, everything would be dark and we wouldn't have a tool to predict what else is out there. Now with sensing, we also rely on basically the same thing. We rely on observing electromagnetic energy from other Wi-Fi device transmissions, which originate from locations throughout the home environment. As these waves propagate towards the access point from the device, they interact with the environment by reflecting off different objects, different surfaces, or even people. It's the job of our algorithms to understand these properties and allow us to predict human motion. Since Wi-Fi operates using fixed frequencies, our observations are really limited. They're limited to 2.4 gigahertz, 5 gigahertz, 6 gigahertz, and also 60 gigahertz. And they're also limited in bandwidth as well. With astronomy, we're limited to our point of observation being in or around Earth. We are constrained in where these measurements can take place, and therefore the information that we have is somewhat limited. Voyager 1 and 2, actually one of the most interesting exploration projects that we've undertaken as humanity, launched roughly 43 years ago, and they're now the furthest man-made objects from Earth. The vast knowledge that they were able to provide came from observations that were not possible to be made on Earth. With sensing, we are also constrained in where measurements can occur. Slightly different though, sensing constraints are influenced by existing standards and regulations. For example, Wi-Fi being initially designed for digital communications, and as a result, device limitations were placed on who can talk to who based on their role. With sensing today, it's more practical to have the observations occur on the access point because the access point is able to talk and listen to all of its associated clients. So this gives us the ability for it to measure, for it to perform more different types of measurements. With astronomy, our observations and understanding is limited. Kind of a funny slide here, but With more advancements in models and technology, we've been able to improve our understanding and our accuracy. It really wasn't until Galileo pointed his telescope towards Jupiter and was able to see that there were moons orbiting Jupiter that really caused us to turn what we understood upside down and really understand the true position of where the major bodies are in our solar system. So that really goes to show that even though we're making observations, it's not until you are able to use the right technology to make them, you can build the correct model to understand what you're trying to see. Wi-Fi sensing also gains with technology advancements. As Wi-Fi coverage and reliability improves, we begin adding more devices to our networks. Advancements also happening in the semiconductor space allow for higher computation abilities, which gives us the ability to integrate more intelligence into a single component. Other things that we've done is increase bandwidth and higher order MIMO, allow for better resolution sensing, and additional frequency bands that are opening up allow for better properties to be exploited. In astronomy, if we were able to make observations from different locations, we could get a better and more detailed picture. Voyager 1 and 2 still operating today. By viewing the solar system from where they're currently located, we have been able to greatly improve our understanding, which is still being updated today as they return data to us. Wi-Fi motion has also made some comparable advancements. We have added the ability to incorporate multiple antennas into our home Wi-Fi devices. This gives us a slightly different observation, so it gives us a spatial diversity aspect. But today, more importantly, what helps is, especially for large environments, is deploying multiple access point systems throughout your home and performing the measurements on the different access points. So this is possible using today's standards and technology, but there are still limitations in who can talk to who. If we compare this back to the astronomy case, this is very similar to us saying that we can only see a certain number of stars from point A and only see a certain number of stars from point B. So kind of removing this limitation is certainly something that new standards can help us improve. What's the industry been doing to help enable the technology advancements? Well, back in 2019, the WBA first formed the Wi-Fi Sensing Group, which produced its first white paper highlighting business opportunities, potential use cases, and areas where standard improvements could help grow the technology. There's also been significant improvement in the IEEE around this topic. PAR and CSD has recently been approved, and now there's a task group which is forming this week actually to focus on defining new additions into the standard for sensing. One other thing to point out is the WBA Sensing Group has also been busy doing work this year. We've been working on developing a test methodology around sensing, and with big help from the WBA members, we conducted a pretty thorough evaluation case study. So the methodology and case study that we performed is expected to be published hopefully sometime before the end of this year. So what will further expand Wi-Fi sensing? Well, I hope that some of the analogies that I made from this presentation help spark some creative thinking from everybody, because creativity is certainly going to be something that the industry is going to need as we come together to define more standardization. Just to give everybody a short teaser from the Wi-Fi Sensing Group's work this year, one major area that we highlighted is the need for industry standard tools to test sensing. There's a ton of tools that are available for testing all of the digital communication aspects of Wi-Fi, but as sensing becomes deployed as a more as a new Wi-Fi service, we're going to need different tools to test and validate the deployment. Finally, one other thing I want to mention is for any WBA members, the Wi-Fi Sensing Group has proposed a third phase sensing project, and this project is looking to analyze and develop a set of deployment guidelines for different types of home environments. So anybody who's a member and who's interested, please take a look at the proposal and certainly cast your vote. Just the last statement that I want to make is the industry needs to start planning now for adopting this technology. A typical home replaces its access point or gateway roughly every 4 years or so, meaning that the systems that get deployed today will stay deployed for quite a long time. So when you design these systems, we need to keep sensing as an application in mind. Just to close, one last thing I want to say is Wi-Fi Motion is taking off. It's in the market now and it's gaining wider deployment and it's always advancing. So with that, I end my presentation and I thank everybody for their attention.
Great, thank you, Chris, and great call to action for anybody who's interested in sensing. Please join the WBA work group. That's one of the things I love about the WBA. You know, we put on these events and now webinars, but we're not a conference organization at heart. We're actually folks who like to roll up the sleeves, make things happen, define things, and then test them and show them. So, and Wi-Fi sensing is no different. So, if you have an interest in this area, please reach out to Chris. There is a question for you, Chris, fairly open one, but why is standardization important, I guess, in the context of sensing?
Yeah, very, very good question. A couple of different dimensions, I guess, to touch upon is the applications that it enables. The first thing is there's a lot of potential for this technology, but it's built upon things that already exist in the Wi-Fi standard, which was really designed for communication. It was designed with communication in mind. But to enable sensing applications, there's a lot of work that has to be done to make things more deterministic. We need proper protocols for performing these measurements. I mentioned the case from the slides about the multi-access point network. Right now, only the access point can talk to the clients that are associated to it. Even though they're part of the same network, the clients that are associated to other access points can't be used or cannot be measured by the access point where it's not associated. So certainly wrapping everything up and creating a standardized protocol for all of this to happen will grow the potential for use cases. I guess one other point I want to make is there's a lot of proprietary components right now with sensing. So different implementations behave differently. That's a big challenge. All of this has to be cleaned up if we really want to make everything uniform. So I think those are the big areas that standardization will help.
I'm sure you're right. It's till these things get sorted out, it's difficult to scale things sometimes. Okay, look, that was a question. I've got another question in here. Also, is privacy an issue with this technology, and how is it addressed?
Yeah, so by design, it is private. Some of the competing technology for home monitoring are things like cameras. A lot of people don't want cameras in their house, and one of the great things about this technology is it's not adding additional cameras into your house. It's using signals that are already there. It's not allowing people to visually see what's going on in the house. It's providing a level of context, which kind of takes the privacy aspect out of it. So by design, this technology has privacy built in.
Good, is what I say. All right, I'm mindful of time, and we've got a huge number of people still on the call, so I thank you everybody for staying through and listening to all of our speakers. A really good tour de force and tour around the next decade of Wi-Fi, from Wi-Fi 7 to really good understanding of Wi-Fi 6 and 6E, to the world of enterprise and how that converges with private LTE and 5G. Some interesting views about, you know, what technologies we can use to work from home and how to optimize that as an enterprise experience needs to be sort of taken at home. And then, as you've heard here, around Wi-Fi sensing, and I shouldn't, of course, forget the the super smart antennas from Huawei. Anyway, I think we'll now move on to the close. So Sarah, have you got this? Yep. So look, thank you everybody for joining the webinar. A big thank you to our sponsors, to Boingo, to Cisco, to Intel, my own company, Global Reach, Aptillo, SAI, Cognitive, Huawei, Juniper, On, Semiconductor On, Single Digits, STL, and Y Connect. Thank you so much. Thanks for joining. Our next event comes to you on Thursday, November the 5th, what we call Bonfire Night here in England, and I will be presenting on that. I won't be moderating, so please come back. We've got some fantastic speakers there and topics on transforming public and guest Wi-Fi services. So a big thank you to all our speakers. Thanks for the effort you put into preparing for this and delivering it, and thanks for joining. See you again soon.
Thank you.